If you're studying SAP plant maintenance, you know how easy it is to get lost in the details. But to really get ahead, you've got to see the big picture. And that's exactly what we're going to do here. Connect all the dots so you can really master these concepts. Okay, let's just dive right in. Seriously, understanding the why behind S4HANA makes learning the how so much easier. You have to remember this isn't just another software update, it's a completely different way of thinking about how a business should run.
So here's how we're going to break it all down for you. We're starting way up high with the big picture vision. Then we'll get into the key technologies that make it all happen. And finally, we'll look at the real-world choices companies have to make about where to run their systems.
First up, we need to unpack this huge idea that's driving pretty much everything SAP does these days, the intelligent enterprise. And I know it sounds like a buzzword, but trust me, it's the core philosophy behind it all. So what does that really mean? Well, it's this vision for a business that doesn't just sit around and react to problems. Instead, it anticipates them. It responds proactively. For asset managers, predictive maintenance is the perfect example of this in action. The whole point is to use your data to work smarter, not just harder.
This whole vision is really built on three big pillars. First, you've got the intelligent suite. These are the core apps you're in every day. Then, there are the intelligent technologies, things like AI and the Internet of Things, that make those apps smart. And finally, tying it all together is the digital platform, the foundation that manages all the data and lets everything run smoothly.
All right, so how does SAP actually build this thing? Well, it all comes down to three of the most important acronyms you'll hear: BTP, HANA, and S4HANA. Understanding how these three fit together is absolutely crucial.
Okay, so think of BTP as your ultimate toolbox for innovation. This is that digital platform pillar we were just talking about. It lets companies build new things, connect all their different systems, and really innovate, all without messing with their core operations. It's a platform that runs in the cloud, on services you already know, like AWS or Azure.
Now, HANA. HANA is the super fast engine under the hood. The key thing to get here is that it's an in-memory database. That means it's pulling data straight from super fast RAM instead of a slower disk drive. This is what makes real-time analytics possible and lets the whole data structure be way simpler. And that brings us to the star of the show, S4HANA. This is the modern business suite, that intelligent suite pillar, and it is built from the ground up to run on that incredibly powerful HANA engine. It's the successor to the classic SAP ERP system you might have used before. So, what's the big deal? What are the actual benefits here? Well, because it runs on HANA, the data model is just radically simplified. We're talking fewer tables, no more redundant data. This shrinks your data footprint, and when you pair that with a modern user interface called Fiori, the whole system just feels faster, simpler, and way more intuitive to use. Okay, so we know what S4HANA is, but now for the million-dollar question. Where is this system actually going to live? And believe me, this choice has massive implications for cost, flexibility, and who has to do the maintenance.
At its core, the choice really boils down to owning versus renting. It's that simple. With on-premise, you buy it all, you own it all, you manage it all yourself. With the cloud, you're basically renting it. You pay a subscription, and the provider takes care of all the heavy lifting in the background.
This is such a great way to think about it. The public cloud is like an apartment building. You and a bunch of other companies, the tenants, are all sharing the same building, the same infrastructure. This makes it super efficient and affordable. And the best part? The landlord, or the provider, handles all the maintenance. And on the flip side, you have the private cloud. This is like owning your own single-family house. The whole place is yours. You get dedicated resources, which means you have total control to customize and change things however you want. It's more responsibility for sure, but for a lot of big companies, that control is absolutely essential.
This slide really maps out the whole spectrum. You can start completely on-premise, where you do everything. The first step into the cloud is usually IaaS, Infrastructure as a Service. You're renting the servers, but you still manage the software. Then there's PaaS, Platform as a Service, where you just manage your apps. And at the far end is SaaS, Software as a Service, where you pretty much just log in and use it. The provider handles everything else.
But here's the thing. What if one size doesn't fit all? For huge global companies, it's rarely that simple. They often need something a little more sophisticated than just picking one single model. And that is exactly where two-tier ERP comes into play.
It's a really powerful strategy where you mix and match. You get the best of both worlds, right? You can have that deep control and customization of a private system at headquarters combined with the speed and standardization of a public cloud for all your smaller divisions.
And you see this strategy play out in a few common ways. The classic one is the headquarters and subsidiary model. But you might also see a specific department, like finance, run as its own central service in the cloud. Or you could even have an entire ecosystem model, where a company brings all its partners and suppliers onto one standard platform.
So, as you keep going with your studies, I want to leave you with a final thought to chew on. For the future of asset management, we're talking IoT sensors, predictive maintenance, all that cool stuff. What's really the better path forward? Is it the fast innovation and standards of the public cloud, or is it the total control and customization of a private one? There's no easy answer, and it's the puzzle that businesses are trying to solve right now. Thanks for joining me.
Today we are diving deep into the world of SAP Asset Management. We're going to talk about how some of the world's biggest companies manage their most critical and expensive physical assets. You know, things like entire power grids or those giant robots in a factory. Ready? Let's jump right in.
So, I want you to picture this. Imagine you're in charge of a huge manufacturing plant or maybe an offshore oil rig. How do you manage a multi-million-dollar piece of machinery and keep it running perfectly? Not just for today or this week, but for its entire lifespan. We're talking maybe 30 years. From the first sketch on a napkin to its final retirement, that is the core challenge we're looking at. So here's how we're going to break it all down. First, we'll talk about the main challenge with modern assets. Then we'll walk through an asset's entire life. After that, we'll get into the specific SAP tools that get the job done, see why connecting everything is so important, and finally, check out what it's like to actually use the system.
Okay, so at its heart, asset management is really just a constant balancing act. On one hand, you're trying to push your equipment to perform at its absolute peak, to be as reliable as possible. But on the other hand, you have to keep your costs for operations, for maintenance, as low as you possibly can. And it's that tension right there between performance and cost that every single organization is dealing with.
So how do you actually win that balancing act? Well, you've got to step back and look at the whole picture. It isn't just about fixing things when they break. No, it's about managing that asset through its entire life. This whole journey, from the very first idea to the day you finally get rid of it, that's the asset lifecycle. And that's really the playbook for doing this smartly.
And here's what that journey looks like step by step. It all starts with planning the investment. Should we even buy this thing? Then you get into the actual project, buying all the parts and putting it together. Once it's up and running, your focus shifts to day-to-day maintenance and, of course, worker safety. All while you're constantly keeping an eye on how it's performing, both technically and financially. And then, way down the line, you have the planned shutdown and disposal. A really great system has to handle every single one of these stages without a hitch. Now, managing that entire life cycle, that obviously takes a very specific, very powerful set of tools. So let's actually look at the solutions SAP has to make all of this happen.
First up, you've got SAP Intelligent Asset Management, or IAM. You should think of this as the smart layer. It's the predictive brain of the operation. It's all cloud-based, and it uses data, sensor readings, you name it, to predict problems before they actually happen. The whole goal here is to stop failures in their tracks and get away from just reacting to problems. Then there's SAP S4HANA Asset Management. This is the foundation, right? It's the central nervous system for the whole thing. This is the core system where all the really important stuff lives. All the asset data, the work orders, the maintenance history. The smart predictions from IAM, well, they feed right into this core system to create work that people can actually do. And this is where the rubber meets the road. The SAP Service and Asset Manager. That's the mobile app. It takes all that great data from the S4HANA core and all the smart insights from IAM and puts it right into the hands of the technician who's out in the field, on their tablet or phone. It's that final crucial link connecting the whole system to the person actually doing the work. Okay, so those three tools are incredibly powerful, for sure. But that's not the whole story. The real magic, the absolute superpower of using a system like SAP, isn't just about one of those tools. It's about how they are all deeply, automatically connected to every other part of the business. And this table really shows you what I mean. Let's just follow one tiny task. A technician uses a spare part. The second they record that on their app, bam! The system automatically tells materials management to reserve a new part from the warehouse.
It tells financial accounting to post the cost. It updates the controlling team so they can see their planned budget versus what they're actually spending in real time. It even checks with HR to make sure the technician is qualified for the job. This kind of seamless flow just gets rid of the paperwork and gives everyone a live, complete picture of the business. It lets you make way smarter decisions way faster.
So we have this incredibly powerful, super integrated system. But what's it actually like to use it? You know, in the old days, systems like this could be, well, let's just say they were complicated. The whole approach now, though, is to make all of that complex work feel simple and easy.
And a thing that brings that modern approach to life is the SAP Fiori Launchpad. You can just forget about those old, clunky, text-heavy screens. Fiori is a clean, modern, central place for every single user to start their day. It's designed to give people exactly what they need to do their job and nothing else. So what does that really mean for a person using it? It means you have one place to go for everything. The screen you see is totally personalized for your job. A maintenance planner is going to see something totally different than a technician in the field. It works great on any device, and because it just runs in a web browser, there's nothing complicated to install. It's all about getting users the info they need as fast and as easy as possible. You know, after looking at the whole life cycle, the tools, the integration, the user experience, it all really comes back to this one single idea. This quote nails it. This is the guiding principle behind everything we've talked about. Every single feature is there to hit that one ultimate goal, getting the best performance you can at the lowest possible cost.
And that kind of leaves us with one last thought to chew on. With systems like this, our assets are basically starting to talk to us through data. They're telling us when they need maintenance, how they're performing, where we can make things better. So the real question for the future is, when your most critical assets can finally speak to you, what's the very first thing you're going to ask them?
We're going to map out the entire journey of an SAP S4HANA asset management implementation. So whether you're deep in study mode for a certification or you're about to kick off a real-world project, this is for you. We're going to break it all down. So this is the big question, right? How in the world do you build a modern asset management system from scratch? It can feel, well, overwhelming. But the good news is SAP has a structured answer for this, a methodology that's basically our roadmap for the whole process. Okay, here's a quick look at what we're covering. We'll start with the main roadmap. Then we'll look at the public cloud path versus the on-premise and private path. After that, we'll check out the tools for customizing your setup and finish up with something super important, the simplification list. All right, let's jump right in. We're starting with the implementation roadmap. See, every successful project needs a plan, and in the SAP S4HANA universe, that plan has a name, SAP Activate. So what is SAP Activate? The best way to think about it is like the official GPS for your implementation. It's not just some friendly advice from SAP, it's the standard methodology. It lays out all the phases, all the tasks, and all the deliverables you need to get from point A to point B and beyond. And the engine behind this whole thing is the roadmap viewer. Now, this isn't some dusty old PDF you download once and forget about. No way. This is a living, breathing guide. SAP is constantly updating it, so you're always working with the latest instructions, the latest project accelerators. Everything you need is right there and up to date. Okay, now let's talk about the different paths you can take. First up, the public cloud path. If there's one word you need to remember here, it's standardization, and that's all about using prepackaged processes. So in the public cloud world, everything is delivered through these things called scope items. You can think of them like pre-configured Lego blocks. Instead of building everything from scratch, you're picking and choosing the ready-to-run business processes your company needs. It's all about getting you up and running fast. And here are some of those building blocks in action. Now, if you're studying for a certification, pay close attention to that status column. See how older scope items like BH1 and BH2 are marked as deprecated? They've actually been replaced by newer, better processes like reactive maintenance. It's a perfect example of how the platform is always evolving. All right, so that was the public cloud. Now let's switch gears and look at the other main path, the on-premise and private cloud route. This one is all about flexibility. It's for companies that really need to tailor the system to their unique, specific ways of working. And here's the fundamental difference from the public cloud. On this path, you actually get a choice. You can still use those scope items we talked about as a great starting point for a fast deployment, or you can roll up your sleeves and dive into the classic implementation guide, the IMG, and configure everything manually. You get to decide. You'll probably recognize a lot of these scope items. They're similar to the ones for public cloud. But here's the catch. On this path, things like BH1, corrective maintenance are still available. Why? Because they serve as a really powerful foundation, a starting point that you can then build on with your own manual configurations and customizations. Okay, so you've picked your path, standardized or flexible. What's next? Well, now you need the right tools to actually tailor the system and get it just right for your business. And this is where we hit a real fork in the road when it comes to tools. If you're on the public cloud, it's pretty straightforward. You have one mandatory tool for everything, and it's called SAP Central Business Configuration. But if you're on the private cloud or on-premise path, your flexibility comes from something called business functions, which you basically switch on to add new features. Let's look at the public cloud side first. That Central Business Configuration tool, or CBC, walks you through a really clear three-step process. First, you define your scope. Then you set up your org structure. And finally, you get into the nitty-gritty of product-specific configuration. Simple as that. Now, on the other side of that fork, we have business functions. The best way to think of these is like feature packs that you can just switch on. It's almost like an app store for your system. Say you need some really advanced refurbishment capabilities, you just find the right business function, flip the switch, and boom, that new functionality is unlocked in your system. And here's a little pro tip for you. The naming convention is actually a fantastic cheat sheet. It tells you exactly what you're getting. If you see log_EM_CI in the name, the CI stands for continuous improvement, usually for the classic UI. See simplicity? That's going to be a modern web app. It's a really logical system that kind of demystifies the whole process. Okay, last section, and this one is absolutely crucial. Before you start any implementation or upgrade, you have to check the travel advisories. And in the SAP world, that essential document is called the simplification list. You cannot skip this. So what is it? I mean, this document is basically your non-negotiable reading list. It tells you, in plain terms, what applications, transactions, and functions are gone, no longer supported in S4HANA. Seriously, ignoring this is like trying to drive from New York to LA without a map, and without checking for any road closures. You're just gonna get stuck. But here's the most important part to understand. It's not just about SAP taking things away. It's about strategic replacement. The whole point is to replace older, sometimes clunky functionality with something new, something simpler, something better. And the simplification list doesn't just tell you what's gone, it tells you what the new shiny successor application is. And here's why you have to pay such close attention. First, it is release dependent. That means the list for version 2023 is different from 2022. You have to check the latest version for your project. Second, the impact is huge. We're talking both business impact, how people do their jobs, and technical impact, like custom code that might break. It touches everything. So that leaves us with one final thought. As you can see, SAP is constantly evolving. So the big question for you is, how are you going to stay ahead of things like the simplification list? Because mastering S4HANA isn't something you do once, it's a continuous journey. And keeping up with these changes, well, that's what separates the real experts from everyone else.
Have you ever wondered how a massive company is actually built inside of SAP? Well, today we are laying down the essential blueprint for a powerful asset management system in S4HANA. And trust me, if you get this first step wrong, the entire structure can come crashing down. So let's dive in.
Okay, picture this. Your company is all in on SAP Asset Management. It's a huge project, and you're staring at what feels like a blank screen. With all the complexity, with everything you could do, where on earth to even begin?
And the answer is right here. Before you create a single piece of equipment, before you write one maintenance order, you have to build the house that it's all gonna live in. It all starts with the organizational structure. You know, getting this blueprint right isn't just important, it is everything.
So here's the roadmap for today. We're going to start with the overall blueprint. Then we'll zoom in from that high-level corporate view right down into the heart of maintenance, the plants. From there, we'll see where the work actually gets done, look at some key strategic choices, and then finally, we'll connect it all back to the people who make the whole system tick.
First up, let's talk about that blueprint.
This isn't about just jumping into the system and creating stuff at random. Oh no, it's a very deliberate process that takes you all the way from analyzing your business to configuring the system to be a perfect match. It really boils down to this logical three-step process. First, you analyze your real-world company structure. How do you actually operate? Then you define that structure in SAP. And finally, you assign all the pieces together so they can talk to each other. Analyze, define, assign. Remember that. Trying to skip any of these is like building a house without a plan. It's just a recipe for disaster.
All right, let's start our tour of that structure. We're going to kick things off way up high at the 30,000-foot view, and then we're going to zoom all the way down into the nitty-gritty details.
At the very, very top of everything is the client. Now, I want you to think of the client as the entire universe for your company inside SAP. It's the big mothership, the parent corporation, the container that holds absolutely everything. All your companies, all your data, all your processes. So if we take one step down from the client, we find the company codes. These are your individual, legally separate companies or subsidiaries. Each one has its own set of books, its own balance sheet. So you could have one big corporate group, that's the client, that contains, say, a different company code for its business in the US, another for Germany, and another for Japan.
And now we're getting down to the ground level. We're talking about the plant. This is the physical place, a factory, a production site, a warehouse, where your assets, your equipment actually live and breathe, and where the maintenance work gets done. For us in asset management, this is one of the most important levels, period.
The plant is so important, in fact, that we need to give it its own spotlight. It truly is the heart of maintenance. It's where the assets are, and it's also where the work gets planned. But, and this is a big but, it's not always quite that simple.
And this is a really critical concept you have to grasp in SAP. The system actually separates the idea of a maintenance plant, that's where the physical machine is located, from the planning plant, which is where the team that plans the maintenance work sits. Now, they can be the same place, but as we're about to see, they don't have to be.
Which brings us to this key point right here. For a lot of companies, maybe smaller ones or ones with a decentralized structure, it's super common for a single plant to be both. The machines are there and the planners who schedule the work are also sitting right there in the same building. This is the simplest, most straightforward setup you can have.
Okay, so we've nailed down the where, the plants. Now let's get even more granular and talk about the who and the how. Let's meet the specific groups and people who actually roll up their sleeves and do the maintenance.
And that brings us to the Maintenance Work Center. This is the unit in SAP that represents the actual capacity to perform work. A work center isn't just a physical spot. It could be your team of electricians, it could be a single highly specialized mechanic, or it could even be a specific machine used for calibrations. It's the resource that actually does the job.
So how do we represent all these people in the modern S4HANA system? The answer is the business partner. This is now the central, absolutely mandatory way to create master data for any person, group, or organization. Think of it as the one master record to rule them all.
And this slide just shows beautifully how it all comes together for one single employee. You've got an SAP user ID so they can log in. You've got a personnel number that HR uses for payroll and all that fun stuff. And then you have the business partner, which is the central linchpin that connects those two together, creating one unified digital identity for that person across the entire system. Pretty slick, right?
So, now we have all of our building blocks, right? We've got plants, we've got work centers, we've got people. The next big question is, how do we arrange them? And this is where your company's strategy really comes to life, especially when deciding between centralized or local planning. This lays out the two main strategies perfectly. On the left, you have plant-specific or decentralized planning. Each location handles its own maintenance planning. It's fast, it's agile, it's simple. On the right, you have cross-plant or centralized planning. Here, you have one main planning hub that handles the work for several other maintenance plants. This is awesome for standardizing your procedures or pooling really specialized talent, like having one central team of expert engineers for the whole company.
Okay, we have built the entire structure from the 30,000-foot view all the way down to the individual teams. But a structure, as we know, is totally useless without people. So for our final section, let's connect this entire framework back to the real-world jobs people do every single day.
And that connection happens through something called SAP Business Roles. A role is pretty much a digital job description. It bundles up all the specific apps, all the screens, and all the permissions that a person in a specific job needs to do their work. It's the reason a maintenance planner sees a completely different set of tools than a maintenance technician does when they log in.
And here's how that team comes together. You've got the planner, who's the strategist scheduling all the work. You've got the technician, who's out on the front lines with the tools, making the repairs. You have the supervisor, who's leading the team and checking the work. And working behind the scenes, you have the master data specialist, who makes sure the foundation of the system stays clean and accurate. Every single role is a critical piece of the puzzle.
You know, this quote from the source material really nails it. The entire system, this whole organizational structure we just walked through, it's all designed for one single purpose: to help people in their specific roles get their jobs done well. The structure is there to serve the people, not the other way around.
So if there's one thing you take away today, let it be this. Building your org structure is not just some boring technical task you have to check off a list. A well-defined, logical structure that actually mirrors your real business is the absolute non-negotiable foundation for having an efficient and successful asset management system in SAP.
So, I'm going to leave you with a question to chew on. We've seen the planners, the technicians, the supervisors, the data specialists. In your opinion, which one of those roles is the absolute linchpin? The one role that, if it's not done well, the whole thing falls apart. Drop your answer in the comments below. I'm really curious to see what you all think.
Have you ever wondered how a massive company is actually built inside of SAP? Well, today we are laying down the essential blueprint for a powerful asset management system in S4HANA. And trust me, if you get this first step wrong, the entire structure can come crashing down. So let's dive in.
Okay, picture this. Your company is all in on SAP Asset Management. It's a huge project, and you're staring at what feels like a blank screen. With all the complexity, with everything you could do, where on earth to even begin?
And the answer is right here. Before you create a single piece of equipment, before you write one maintenance order, you have to build the house that it's all gonna live in. It all starts with the organizational structure. You know, getting this blueprint right isn't just important, it is everything.
So here's the roadmap for today. We're going to start with the overall blueprint. Then we'll zoom in from that high-level corporate view right down into the heart of maintenance, the plants. From there, we'll see where the work actually gets done, look at some key strategic choices, and then finally, we'll connect it all back to the people who make the whole system tick. First up, let's talk about that blueprint. This isn't about just jumping into the system and creating stuff at random. Oh no, it's a very deliberate process that takes you all the way from analyzing your business to configuring the system to be a perfect match. It really boils down to this logical three-step process. First, you analyze your real-world company structure. How do you actually operate? Then you define that structure in SAP. And finally, you assign all the pieces together so they can talk to each other. Analyze, define, assign. Remember that. Trying to skip any of these is like building a house without a plan. It's just a recipe for disaster. All right, let's start our tour of that structure. We're going to kick things off way up high at the 30,000-foot view, and then we're going to zoom all the way down into the nitty-gritty details. At the very, very top of everything is the client. Now, I want you to think of the client as the entire universe for your company inside SAP. It's the big mothership, the parent corporation, the container that holds absolutely everything. All your companies, all your data, all your processes. So if we take one step down from the client, we find the company codes. These are your individual, legally separate companies or subsidiaries. Each one has its own set of books, its own balance sheet. So you could have one big corporate group, that's the client, that contains, say, a different company code for its business in the US, another for Germany, and another for Japan.
And now we're getting down to the ground level. We're talking about the plant. This is the physical place, a factory, a production site, a warehouse, where your assets, your equipment actually live and breathe, and where the maintenance work gets done. For us in asset management, this is one of the most important levels, period.
The plant is so important, in fact, that we need to give it its own spotlight. It truly is the heart of maintenance. It's where the assets are, and it's also where the work gets planned. But, and this is a big but, it's not always quite that simple. And this is a really critical concept you have to grasp in SAP. The system actually separates the idea of a maintenance plant, that's where the physical machine is located, from the planning plant, which is where the team that plans the maintenance work sits. Now, they can be the same place, but as we're about to see, they don't have to be. Which brings us to this key point right here. For a lot of companies, maybe smaller ones or ones with a decentralized structure, it's super common for a single plant to be both. The machines are there and the planners who schedule the work are also sitting right there in the same building. This is the simplest, most straightforward setup you can have.
Okay, so we've nailed down the where, the plants. Now let's get even more granular and talk about the who and the how. Let's meet the specific groups and people who actually roll up their sleeves and do the maintenance. And that brings us to the Maintenance Work Center. This is the unit in SAP that represents the actual capacity to perform work. A work center isn't just a physical spot. It could be your team of electricians, it could be a single highly specialized mechanic, or it could even be a specific machine used for calibrations. It's the resource that actually does the job.
So how do we represent all these people in the modern S4HANA system? The answer is the business partner. This is now the central, absolutely mandatory way to create master data for any person, group, or organization. Think of it as the one master record to rule them all.
And this slide just shows beautifully how it all comes together for one single employee. You've got an SAP user ID so they can log in. You've got a personnel number that HR uses for payroll and all that fun stuff. And then you have the business partner, which is the central linchpin that connects those two together, creating one unified digital identity for that person across the entire system. Pretty slick, right?
So, now we have all of our building blocks, right? We've got plants, we've got work centers, we've got people. The next big question is, how do we arrange them? And this is where your company's strategy really comes to life, especially when deciding between centralized or local planning. This lays out the two main strategies perfectly. On the left, you have plant-specific or decentralized planning. Each location handles its own maintenance planning. It's fast, it's agile, it's simple. On the right, you have cross-plant or centralized planning. Here, you have one main planning hub that handles the work for several other maintenance plants. This is awesome for standardizing your procedures or pooling really specialized talent, like having one central team of expert engineers for the whole company. Okay, we have built the entire structure from the 30,000-foot view all the way down to the individual teams. But a structure, as we know, is totally useless without people. So for our final section, let's connect this entire framework back to the real-world jobs people do every single day. And that connection happens through something called SAP Business Roles. A role is pretty much a digital job description. It bundles up all the specific apps, all the screens, and all the permissions that a person in a specific job needs to do their work. It's the reason a maintenance planner sees a completely different set of tools than a maintenance technician does when they log in. And here's how that team comes together. You've got the planner, who's the strategist scheduling all the work. You've got the technician, who's out on the front lines with the tools, making the repairs. You have the supervisor, who's leading the team and checking the work. And working behind the scenes, you have the master data specialist, who makes sure the foundation of the system stays clean and accurate. Every single role is a critical piece of the puzzle.
You know, this quote from the source material really nails it. The entire system, this whole organizational structure we just walked through, it's all designed for one single purpose: to help people in their specific roles get their jobs done well. The structure is there to serve the people, not the other way around.
So if there's one thing you take away today, let it be this. Building your org structure is not just some boring technical task you have to check off a list. A well-defined, logical structure that actually mirrors your real business is the absolute non-negotiable foundation for having an efficient and successful asset management system in SAP. So, I'm going to leave you with a question to chew on. We've seen the planners, the technicians, the supervisors, the data specialists. In your opinion, which one of those roles is the absolute linchpin? The one role that, if it's not done well, the whole thing falls apart. Drop your answer in the comments below. I'm really curious to see what you all think. Hey everyone, and welcome. Today we're going to tackle a really core concept in SAP asset management: functional locations. You ever look at a massive factory and just wonder, how do they keep track of every single piece of equipment? Well, this is the system that makes it all possible, and we're going to break down exactly how it works. I mean, just picture it for a second. A huge automotive plant or maybe a sprawling chemical facility. You've got production lines, buildings, HVAC systems, robots, just thousands of things. How in the world do you track the maintenance costs for one specific motor on one specific assembly line? That, right there, is the exact problem that functional locations are designed to solve. So here's our game plan. First, we'll dig into that core maintenance challenge. Then, we'll define what a functional location actually is and how you go about building that digital blueprint. After that, we'll talk about why this whole structure is so critical, and we'll wrap up by looking at how you actually navigate all of this right inside SAP.
Okay, so first things first, we have to really get a handle on the core challenge here. Because before you can maintain anything, you've got to be able to map it. You need some kind of logical representation of your entire physical operation inside the software. You see, without this kind of digital map, you're pretty much flying blind. It's almost impossible to track an asset's history, to analyze costs properly, or to do any kind of effective preventative maintenance. This structure, it is the absolute bedrock of good asset management.
So how does SAP tackle all this potential chaos? Well, it's with a concept called the functional location. And believe me, this is the fundamental building block for pretty much everything that comes after.
Okay, that sounds a little technical, right? Let's break that down. Just think of it like a digital blueprint for your entire facility, or maybe like a family tree for your assets. The key thing to remember is it's not the asset itself, it's the place where an asset is installed. And it's hierarchical, which just means it has levels, kind of like a folder system on your computer, going from the big picture down to the really specific details.
Now here's what's really powerful. It's flexibility. As you can see from these illustrations, you can structure your blueprint in a few different ways. You could do it spatially, like the layout of a building. Or you could do it technically, based on a machine's components, almost like an exploded diagram. Or even functionally, based on its role in a process, kind of like a flowchart. The trick is just choosing the logic that makes the most sense for your business.
All right, so we get the what and the different ways to organize it, but how do we actually build this thing in SAP? What are the rules of the game? Let's take a look at the tool that pretty much governs the entire setup.
The key to this whole thing is something called the structure indicator. You can think of this as the official rulebook for your entire system. It sets the template for how every single functional location ID is created, which is absolutely crucial for keeping everything consistent.
So this rulebook has two main parts. You've got the edit mask, which controls the format of the ID, things like what characters you can use, letters or numbers, and how they're grouped together. Then you have the hierarchy levels, and that defines the depth of the structure, basically how many sublevels you're allowed to have. So one controls the look of the ID, and the other controls the shape of your hierarchy. All right, enough theory, let's make this real. Imagine we're mapping out a manufacturing plant. Our top level, level 1, is just plant. Super simple. This is our highest, most general location. Now, let's drill down a bit. Inside that plant, we've got a specific area, the assembly line. So our level 2 ID becomes plant assembly. See how the hierarchy's already starting to take shape? We're getting more specific. And for our last level, we pinpoint a very specific spot on that assembly line, the location for Robot 1. Our full ID is now Plant Assembly Robot 1. And just like that, you've got a complete, logical path from the entire plant all the way down to a single maintainable spot. It's brilliant.
So, we've defined it, we've built a little example. But you might be thinking, why go through all this trouble? What's the real-world bottom line payoff for creating this super detailed digital blueprint? This quote from the source material really hits the nail on the head. The whole point of this entire exercise is to break down a massive, complex system into smaller, manageable chunks that actually make sense for your maintenance teams. It's all about creating clarity out of chaos.
And this is where all that structural work really pays dividends. With a good hierarchy, you can record exactly where work was done. You can track costs for one specific area versus another. You can store technical data over years and years. You can even analyze if a certain location is causing equipment to wear out faster. This isn't just about organizing data, it's about gaining some seriously powerful business insights.
Okay, for our last section, let's pull this out of the world of theory and drop it right into the SAP system itself. Where do you find all this information, and what are the actual tools you'll use to work with it? So every single functional location has what's called a master record. Think of it like its profile page inside SAP. It's organized into these key tabs. General data, like manufacturer info, its physical location and address, organizational data, which shows who pays for it, like the cost center, and of course the all-important structure tab, which is what links it into that bigger hierarchy we talked about. Now, to get around and actually manage these master records, you're going to use specific commands in SAP called transaction codes, or T-codes for short. For any SAP student, knowing these is absolutely essential. Take a look at this table. This is basically your cheat sheet. The IL01, 02, and 03 series is for working with just one functional location at a time. You use them to create, change, or display.
If you need to work with a whole list of them, you'll use IL05 or IH6. And my personal favorite is IH01. That's the one that lets you see the entire hierarchy visually, just like that example we built a minute ago. It's super useful. So if there's just one thing you take away from all of this, it's this. The functional location is the number one, the absolute foundation for structuring all of your technical assets in SAP Plant Maintenance. Everything else is built on top of this. And there you have it. We've covered the what, the why, and the how. You now have the core knowledge of the blueprint that holds up all of SAP Asset Management. So the only question left is, if you were mapping out your own factory, where would you start? What's the first part of the blueprint you would build?
All right, let's dive in. Today, we're going to crack the code on a really fundamental concept in SAP. How in the world do you track a single piece of equipment from cradle to grave in a system that's just massive? Let's break it down. So just imagine you're in a huge manufacturing plant. You're surrounded by thousands of pumps, motors, all kinds of vehicles, and then bam, one of those motors fails. How do you find its life story? You know, how many times has it been repaired? What did those repairs cost? That's the big question, right? And that's exactly what we're going to solve today. So the starting point, the main answer to that motor's life story, is a core SAP object called equipment. You got to think of this as the very first building block for tracking any asset that you need to maintain in the system. So what exactly is an equipment in the world of SAP? Well, the best way to think of it is like that motor's unique passport. Seriously, it's an individual, physical thing that we need to do work on. And every single task, every cost, every bit of its history gets stamped right onto this digital passport. Okay, that makes sense. But you might be wondering, you wouldn't create a passport for every single nut and bolt in the plant, right? Of course not. So what's the actual trigger? When does an object become important enough to get its own unique passport, its own master record in the system? Right, and this is where we get to the why. You create an equipment record when the details really, really matter. If you need to track maintenance costs for that specific motor, not just motors in general, or you need to analyze its performance over several years, or maybe you just need to prove how long it was installed somewhere, that's when you need its unique digital passport. At the end of the day, it's all about giving you the data you need to make way smarter decisions. Okay, so we've got our equipment record, our assets passport, it's all set up. But what happens when that motor isn't actually installed anywhere? What if it's a brand new spare just sitting on a shelf in the warehouse? Or maybe it's a repaired one waiting to be used again. This is where things get a little more interesting, and it introduces a new piece to our puzzle. And here's the kicker. That equipment record, as great as it is for maintenance history, has one huge limitation. It's basically a ghost to your inventory management system. You can't use the equipment number by itself to track that spare motor as part of your warehouse stock. And that's a huge gap in visibility. The key that unlocks this whole thing is the serial number. If the equipment record is the asset's passport, think of the serial number as its shipping label or its UPS tracking number. It's what gives a physical object an identity inside your inventory, linking it to a material so you can actually manage it in the warehouse. So this slide really lays it all out, side by side. On one side, you've got equipment. Its whole focus is asset management, tracking that history, those costs. On the other side, you've got the serial number. Its focus is materials management, tracking the item in your stock. Each one solves a different part of the problem. The real magic, though, happens when you click them together. All right, so let's put it all together. This is where we see how these two concepts team up to create a totally seamless view of an asset's entire life, from the warehouse shelf to the factory floor and right back again. And that is the whole point. By linking the equipment number to a serial number, you get this single, unified view of the physical part. Now, the maintenance team, the warehouse team, even customer service, they can all see and manage the exact same object. Everybody's on the same page. Okay, so let's walk through a real-world example. First, a motor breaks down, so you dismantle it. Because it has that serial number, the system knows exactly where it is and automatically tracks it as it moves into storage for repair. At the very same time, a new spare is taken from that inventory and installed. The whole process is totally seamless because that single physical part is visible to everyone who needs to see it. So, where does all this incredible history get stored? Well, it all gets logged in something SAP calls the usage list. This thing is the ultimate source of truth. It's the official auditable logbook for the equipment. It shows every single place it's ever been installed, when it was removed. It even tracks little data changes, like if you change its cost center. It's got everything. Okay, we've got the concepts down. now let's get our hands dirty, so to speak. For all of you SAP students out there, this next part is for you. This is your toolkit. These are the actual transaction codes, the T codes, you'll be using in the system. Here it is, your practical cheat sheet. So for equipment, if you want to create, change, or just look at one, you're going to use IE01, O2, or O3. Simple, right? And if you need to see a whole list of them, you'll use a report like IH08. Same deal for serial numbers, just with the IQT codes. You'll definitely want to bookmark this one for sure when you're practicing. All right, so let's boil this all down. What are the key things to remember? First, equipment is the asset's passport. It's for tracking its whole maintenance life. Second, serial numbers are its tracking number for managing it in inventory. Third, and most importantly, when you use them together, you get that complete 360-degree view. And finally, the usage list is the official record of that entire journey. And that brings us to the final and maybe the most important question. Knowing all this is one thing, but applying it is everything. Now that you can track an asset's every single move, every cost, every repair, how are you going to use that data? How can you turn all that information into real action that saves money and boosts performance?
All right, let's jump right in. If you're studying SAP plant maintenance, there's a concept you absolutely have to know: the bill of materials. Now, you'll usually hear it called the BOM, and trust me, it's kind of like the secret weapon for organized, efficient maintenance. And today, we're going to break it all down.
So here's what we've got on tap. We're going to start with what I like to call the spare parts puzzle. Then, we'll introduce the bill of material as the hero of our story. We'll dive into the specifics of the maintenance BOM, look at a really smart strategy for using them, see how it all works in practice inside SAP, and finally, we'll tie it all together with why this structure is such a big deal.
Okay, first things first. Before we can appreciate the solution, we really need to understand the problem the bills of materials were created to solve.
So let's imagine this. Your plant has, say, 100 identical pumps. A technician goes out to fix one, gets it all taken apart, and whoops, wrong gasket. We've all been there, right? So the big question is, how do you possibly manage the spare parts for all those pumps efficiently? How do you make sure your team has the right part for the right pump at exactly the right time?
Well, without a proper system in place, it's pretty much just chaos. You've got incorrect parts showing up, repairs get delayed, and technicians are just wasting valuable time trying to hunt down what they need. And that exact mess, that's the challenge that a well-structured bill of materials is designed to fix. So, that brings us to our solution. Let's talk about the bill of material. Don't let the simple name fool you. This is an incredibly powerful concept in SAP. So, what is it really? At its heart, a BOM is just a structured list. You can think of it like a recipe. It tells you all the ingredients, or in our case, the spare parts, that make up a technical object, like a pump or an engine. It's designed specifically to help with planning for maintenance. But here's something that might surprise you. The whole idea of a BOM isn't just a maintenance thing, not at all. You'll actually find them being used all across a company, but different teams will use their own versions for totally different reasons. And this table just lays it out perfectly. You know, for the engineering and design folks, their BOM is the master blueprint. It has every single nut, bolt, and wire. But then you head over to production, and their BOM is more like an IKEA instruction manual. It only shows the parts needed to actually assemble the thing. And then there's the costing team. For them, the BOM is all about the money. How much do all these parts cost? See, same concept, 3 completely different jobs. Okay, so now that we've got that wider context, let's zoom in and focus on the one that really matters to us, the maintenance BOM. So what makes the maintenance BOM so special? Well, while those other BOMs are worried about design or how to build something, the maintenance BOM is laser focused. It only contains items that are relevant to plant maintenance. We're talking spare parts, wear parts, the components you actually need to repair and maintain your equipment. And it serves 3 really crucial functions. First, it gives a clear, logical structure to the object from a maintenance perspective. Second, and this is huge, it allows you to easily plan and pull the right spare parts directly into a maintenance order. No more guessing. And third, you can use it in your maintenance task lists, which means you can reuse that planning over and over again. It's all about making things quick, accurate, and repeatable. All right, so now we know what a maintenance BOM is, but there's a smarter way to handle them, a much more efficient way, especially when you're dealing with tons of identical equipment, like our 100 pumps. The key idea is right here. Instead of the nightmare of creating 100 separate BOMs for those 100 pumps, you create just one single bill of materials, and then you assign it to all 100 of them.
This is, and I mean this, a total game changer for efficiency. This really elegant solution has a name. It's called a material BOM. The whole idea is that you create the BOM for a material that represents your standard pump, and then you can link that single BOM to every single piece of equipment that's built the same way. Think about it. No redundant data, zero wasted effort. It's just clean.
And the best part is, the process is pretty straightforward. It's really just 3 steps. Step 1, you create a material master record to represent the object, like our standard pump. Step 2, you create the material BOM, and you link it to that material. And then for step 3, here's where the magic happens. You go into the master record for each individual pump, find the construction type field, and you just pop in that material number. Boom! That's it. They are all now linked to the same master parts list.
Okay, so that's the what and the why. Now let's quickly talk about the how. What are the actual tools you're going to be using inside SAP to make this happen?
For all of you who live and breathe in the SAP system, these are your key transaction codes. The CS01, 02, and 03 series, that's your bread and butter for creating, changing, and displaying material BOMs. And IH05 is a fantastic tool for just getting a clear structural view of your BOM. These are definitely ones to remember.
So let's zoom back out and bring this all home. Why does mastering this structure matter so much? What's the big picture?
Here's the bottom line. By using bills of materials effectively, you transform your maintenance strategy. You move away from that chaotic, reactive scramble for parts that we talked about and into a world of structured, planned, and highly efficient maintenance. It is all about ensuring accuracy, saving time, and empowering your technicians to do their job right the first time.
And that leads us to our final thought. Structuring your assets with BOMs is a massive step forward, a huge win, but it's just one piece of the maintenance puzzle. So it really opens up the question, what comes next? What's the next step on the path to building a truly world-class maintenance operation? Something to think about as you continue your journey in SAP PM.
All right, all you SAP PM students out there, welcome. If you've ever found yourself staring at S4HANA, wondering which maintenance process you're supposed to use and when, well, you are in exactly the right place. Today, we're going to break down the core models so you can nail the perfect one for literally any situation. Okay, so here's our game plan. We're going to kick things off with a classic, real-world challenge. Then we'll walk through the 3 key processing models, one by one. And finally, we'll get to the good part, how to figure out which path is the right one for what you're trying to do. Let's get into it. So let's start by putting ourselves right there on the factory floor. I want you to imagine a situation that, trust me, every single maintenance planner is going to face at some point. So picture it. Alarms are going off. Production has ground to a halt. What do you do? Is this a full-blown, all-hands-on-deck emergency, or is it just a routine fix? Maybe something in between. You know, the answer isn't always obvious, and the process you choose right now, well, that's going to dictate everything that comes next. The good news is SAP gives you some seriously powerful ways to respond.
Okay, so let's start with our first and, honestly, most fundamental process. This is your standard go-to approach for most of your day-to-day repairs. You can really think of this as the bedrock of maintenance. It's the process that gives you control, makes sure you're compliant, and lets you track costs when time isn't the absolute #1 enemy.
Now, what's so important to see here is how this lays out a really logical, deliberate path. It all starts when you formally record the problem. That's your notification. Then you move into planning the work order. You know, what are the steps? What parts do we need? Who's going to do it? And before a single wrench is turned, you check for material availability and get any necessary permits approved. Only then do you execute the work, confirm that it's done, and finally close everything out. It's structured like this for a reason, you guys. It's all about control and traceability. Every single step is a checkpoint, both for operations and for the money guys.
But what if you need even more granular control? For those bigger, more complex jobs, think proactive maintenance or a big improvement project. That simple 6-step process, it just might not cut it. And that's exactly where the phase model comes into play.
I want you to think of this as the high-definition 4K version of maintenance processing. It is perfect for those scenarios where every single stage needs to be meticulously tracked, from the second someone puts in a request all the way to the final financial settlement. We're not talking about a simple pump repair here. We're talking about projects.
And this just brilliantly illustrates that extra level of control we're talking about. See the new phases we've added? Like screening, where you actually vet the request, and a formal approval workflow. You also get these dedicated phases for preparation and scheduling before anyone even starts the execution. This model gives you these super precise checkpoints to make sure that complex work stays on track and, just as importantly, on budget.
But here's the really crucial part. Even this super detailed model is smart enough to have shortcuts built right in. If something is a true emergency, the system can just bypass all that screening and approval and automatically create the order for you. And for really minor stuff, like changing a light bulb, you can handle the entire thing right inside the notification, skipping the whole work order process completely. It's powerful, but it's also flexible.
Okay, let's totally switch gears now. Let's go back to that critical machine that's gone down. Production has stopped. Every single second of downtime is just hemorrhaging money for the company. Welcome to the fast lane.
This quote from the source material, it just says everything. The single defining feature of emergency maintenance is one thing: speed. It is designed to get you from problem to resolution as fast, as humanly, and systematically possible. And it does that by putting everything you need in one place.
As a future maintenance planner, you have to see this as your crisis management tool. The moment you report the malfunction, the system is creating both the notification and the work order in the background at the same time. You plan, you release, you execute, you confirm, all inside the same Fiori app, which is just SAP's modern user interface. It's all about removing clicks, slashing process steps, and empowering that technician to just get the job done, period.
And this table here, it just perfectly wraps up how SAP thinks about breakdowns across all the different models. See, it's not just one single process, it's a concept. You can tackle a breakdown by squishing steps together in the standard corrective model, or by skipping entire phases in the phase model, or by going all in with the emergency maintenance app. Each one is just a different way of hitting the accelerator on a standard procedure.
So, we've looked at the structured path, the highly detailed path, and the lightning fast path. Now you've got these three powerful models in your toolkit. So how in the world do you actually decide which one to use?
Honestly, the main takeaway from this slide is pretty simple. You have to match the process to the problem. For all your routine, non-urgent repairs, just stick with the standard corrective process. For those complex planned projects that absolutely demand tight oversight, you're going to use the phased model. And when a critical machine fails and a whole production line stops, you go straight to emergency maintenance. No hesitation.
So, to wrap this all up, think of it like this. Corrective maintenance is your reliable daily driver. The phased model is your heavy-duty project management tool. And emergency maintenance, that's your fire extinguisher. Really mastering these processes just means you can apply exactly the right amount of structure and speed to any maintenance scenario that gets thrown at you.
And that really is the core question, isn't it? Because choosing the right process, that's not just a system decision, it's a business decision. And as a maintenance professional, it's a question you are going to be answering every single day.
All right, if you've ever worked in plant maintenance, you know that feeling. That moment a critical machine goes down and the chaos that follows. So how do you get from that broken machine on the shop floor to a properly documented, trackable repair inside the system? Well, in SAP, it all kicks off with one absolutely vital document, the maintenance notification. Today, we're going to break down exactly what that is and why it's the bedrock of any solid maintenance program.
So here's the plan. We're going to start with the problem we're trying to solve, then we'll look at SAP's solution. We'll pull it apart to see how it's built, find out how to make it super powerful with something called catalogs, and then finally, we'll check out the actual tools you're going to use. Let's dive in. So, to really get why these notifications are so critical, let's first talk about the problem they were designed to fix in the first place.
Okay, picture this. You're on the shop floor, things are running smoothly, and then bam! A critical pump grinds to a halt. Production stops. What do? Yell for a mechanic? Fire off a panicked email? How do you make sure this thing gets officially logged and doesn't just fall through the cracks?
See, without a real system, you just get chaos. Total undocumented chaos. Once the repair is done, the history of what happened just vanishes. You have no way to figure out why that same pump keeps failing every 6 months. You've got no data to decide what to fix first. Coordination is a mess, and trying to spot trends? Forget about it. This is the exact mess an SAP notification is built to clean up.
And that brings us right to the solution. The tool that swaps out that chaos for structure, for data, and for clarity. And that tool is the SAP Maintenance Notification.
So what is it really? Think of a notification as the official starting pistol for any maintenance task. It's a digital record, a flag in the system that says, hey, something's wrong here or something needs to be checked. It's the system's way of officially logging the problem and starting the clock.
But a notification is way more than just a digital sticky note. To make the data inside it actually useful, SAP uses something called catalogs. Now, instead of just a text box where someone can type, "It's broke," a catalog gives you a standardized list of options to choose from. It's kind of like a multiple choice test for the technician. Is the damage mechanical or electrical? Was the cause normal wear and tear? This structure is absolutely key. It makes sure everyone is speaking the same language. And we can take that multiple choice test and make it even smarter with a catalog profile. What this does is it tailors the available choices to the specific piece of equipment. So for a pump, you'll only see relevant options like leaking seal or bearing failure. You won't see codes that belong to a forklift. This makes logging the details incredibly fast and way more accurate. We'll see why this is such a game changer in a minute.
Okay, so we know what a notification is and why it's so useful. Now let's pop the hood and take a look at its anatomy. What are the actual pieces of information that make up one of these things?
Every single notification is built around these 4 core sections. You've got the header for the general info, you've got items for the specific problems, activities for the work that's already been done, and tasks for what still needs to happen. Let's just quickly touch on each one.
The header is basically the cover sheet. It's the high-level stuff. It tells you what equipment is broken, who reported it, and when they reported it. This info is the main identifier for the entire record.
The items section is where you get into the nitty-gritty of the problems, and this is where the system gets really smart and flexible. Let's say our pump has a leaking seal and a broken pressure gauge. Well, you don't need 2 different notifications. You just create one notification with 2 separate items. It keeps all the related issues for that single event perfectly organized together.
Now, activities are all about looking backward. This section answers the question, what have we done so far? Maybe an initial inspection was done, or maybe a temporary patch was put in place. Documenting activities here gives you a crystal clear audit trail of every action that's been taken.
So, if activities look backward, you guessed it. Tasks look forward. This is your action plan, your to-do list. It answers, okay, what do we need to do next? This could be anything from order new seal to schedule electrician for tomorrow. It's how you plan and coordinate the next steps to get the job done right.
Okay, we touched on catalogs a little earlier, but now I really want to dive into why using these standardized codes isn't just a nice to have, it's a complete game changer compared to just typing in free text.
I mean, just look at this side by side. On the left, you've got free text. It's the Wild West. It's inconsistent. It's full of typos. Is pump is noisy the same thing as motor making loud sound? A computer has no idea. But on the right, with coded entries from a catalog, your data is standardized, it's accurate, it's objective. This right here is the difference between messy data and powerful intelligence. The benefits here are massive. You get clean, reliable data that you can actually use for reports and analysis. You can finally see trends like which part is failing most often across the entire plant. You can even get fancy and have the system automatically trigger workflows. Like, if someone selects the code for a critical safety failure, it could automatically email the plant manager. It's all about moving from just fixing things to truly understanding why they break.
All right, so we've covered the why and the what. Now for the final piece of the puzzle, the how. Where do you actually go in SAP to get this done?
For most people these days, your home base for this is going to be the SAP Fiori Launchpad. This is the modern, user-friendly web-based interface for getting work done in SAP.
On that Launchpad, you'll probably see a few different apps or tiles for creating notifications, because one size definitely doesn't fit all. Request Maintenance is a super simple form that any employee can use. Create Maintenance Notification is the heavy-duty tool for the maintenance planners. And Report Malfunction is like the big red emergency button, a streamlined app for getting urgent issues logged fast. The app you use just depends on your role and what's going on.
Now, I know some of you out there might still be working in the classic SAP Graphical User Interface, or the GUI. And hey, don't worry, all the same power is still there for you.
Instead of clicking on apps, you're going to use what are called transaction codes, or T-codes. This slide is a great little cheat sheet for you. The one you'll probably use most is IW21, which is to create a notification. IW28 is another really powerful one for finding and editing big lists of notifications. These are just shortcuts that take you right where you need to go. You know, at the end of the day, it all comes back to this one core idea, which is captured perfectly in this quote from SAP's own training materials. The notification must include all data that is important to maintain history. This whole process isn't just about fixing today's problem. It's about collecting the intelligence you need to make way smarter decisions tomorrow.
So, we'll end with this question for you to think about. Creating a good notification is the first step. The real power comes from what you do with that data later. Now that you know how to capture clean, structured information about every single failure and repair, how are you going to use that history to move from being reactive to proactive and maybe even predictive? Now that is where this journey gets really exciting.
Hey everyone, and welcome. In this explainer, we're going to be unlocking one of the most important tools in all of SAP plant maintenance, the maintenance order. Seriously, if you work in maintenance, this is the digital command center that pulls every plan, every action, and every single dollar together. All right, let's get into it.
So just imagine this for a second. The main conveyor belt at your plant just grinds to a halt. You've got alarms blaring, production has completely stopped. So, what's the plan? How do you get the right technicians on it, order the correct spare parts, and track all the costs? Well, that whole chaotic mess is exactly the problem the maintenance order was designed to solve. And here it is, the solution. The maintenance order is really the central nervous system for any maintenance task you do in SAP. It's so much more than just a work ticket. Think of it as this all-in-one container for planning the job, actually doing the work, and this is a big one, tracking every single cost along the way. And what makes it so incredibly powerful is how tightly it's integrated with materials, finance, and everything else. It really becomes your single source of truth. To really get a handle on the maintenance order, we've got to look under the hood. You can almost think of it like a project binder. It's made up of these different sections, and each one holds a critical piece of the puzzle that guides the whole process from the moment a problem is reported until the job is done. So here they are, the core building blocks. You've got the order header, which is kind of like the cover sheet, the object list, which is super useful when you're working on a bunch of machines at once. Then you have the operations, that's your step-by-step to-do list. And of course, you've got spots for materials, tools, and all the really important money stuff, like the settlement rule and costs. So let's break a few of the big ones down. First up is the order header, and it's pretty much what it sounds like. This is where all the high-level info lives, the stuff that applies to the entire order. We're talking about who created it, what the job is for, how urgent it is, and those key deadlines. If you just need a quick 30-second summary of the job, the header is the first place you're going to look. Now, the object list is actually a really clever feature. Let's say you need to do the exact same inspection on 10 identical pumps. Well, instead of making 10 different orders, which would be a total pain, you just make one order and then add all 10 pumps to this object list. It is a massive time saver, and it makes sure the work is done consistently across all of them. Okay, now we're getting to the real heart of the order, the operation. This is the action plan. This is the get-her-done part. Each operation spells out a specific step in the task. You know, things like isolate the motor, replace the bearing, or test the functionality. This is where the actual work gets defined and planned out in detail. And, you know, we have to talk about the money. The settlement rule is what answers that all-important question, who's paying for all this? It's basically the billing instructions. It tells the system exactly which cost center or other accounting bucket is going to absorb all the labor and material costs that this order racks up. Right, so since the operations are where all the action happens, let's zoom in a little closer. This is where you really flesh out the who, what, and how of the maintenance job. And honestly, getting this part right is absolutely key to planning and executing the work efficiently. This little table shows some of the most critical fields you'll find in an operation. The work center tells you which team is on the hook for the job. Is it the mechanics, the electricians? The work field is simple. That's the planned labor, usually in hours. Now, the control key is a really powerful setting. It's like a rule book. It can say, for instance, that you have to confirm this step is done before the next one can even start. And then there's the calculation key, which handles all the math. It tells the system how to automatically figure out the job's duration based on the hours and the number of people you assign. It's all right there. And you can even get more granular. A big main operation, something like overhaul pump, can be broken down into smaller sub-operations, like disassemble, clean, and reassemble. But, and this is a really crucial difference, sub-operations are pretty limited. As you can see here, they can't have their own materials assigned, and they don't track costs on their own. They are strictly just subtasks that belong to a main operation. So we've seen the structure of an order, but how do they actually come to be? How are they created? Well, the process is incredibly flexible. It's often kicked off by another key document, the maintenance notification. Let's take a look at how these orders are actually born inside the system. SAP gives you a bunch of different ways to create an order, and it really just depends on the situation. The most common way by far is creating it directly from a notification that reported the problem in the first place. You can even bundle a few notifications together into one big order. But you can also just create a simple direct order for a quick job or a super detailed one for a major project. And for all that routine stuff, orders can just be generated automatically from a preventative maintenance plan. Now, here's a really important point about best practices. While you can create an order directly without a notification first, it's generally not a great idea. And why is that? Well, because the notification is what captures the rich history of the problem, the what, where, and when of the failure. If you skip that step, you're throwing away valuable data that you could use for root cause analysis down the road. Okay, let's circle back to one of the most important jobs of a maintenance order, tracking the costs. Every spare part you use, every hour of labor somebody books, it all gets collected. But how it gets collected is a really critical choice you have to make in the system setup. And that brings us to this fundamental question in SAP PM controlling. Do the costs get collected for the whole order, all together at the header level, or do they get tracked for each individual step, down at the operation level? The answer to that question really determines the level of financial detail you're going to get. The system gives you two very different ways to do this. The default is header level costing. Here, all the costs just roll up into one big bucket on the order header, and there's one settlement rule for the whole job. Nice and simple. But there's a more granular way, operation level costing. With this method, each and every operation gets its own costs and its own settlement rule. This is huge because it lets you see exactly which step of the job was the most expensive. The only catch is you have to choose one or the other. You can't mix them up in the same order. All right, we have gone through the maintenance order from top to bottom, and I know it's a powerful and complex tool, so let's just quickly run through the absolute must-know points from this whole explainer. First, just remember that the maintenance order is that central hub for planning, doing the work, and costing it all out. Its structure, from the header down to the operations, is perfectly designed to bring some order to the chaos of maintenance work. Remember that the operations are the real action plan. And finally, don't forget how flexible it is, both in how you create it and how you decide to manage and settle your costs. So every time you complete a maintenance order, it leaves behind this rich trail of data. What broke, how long it took you to fix it, how much it cost. And this leads us to one last really powerful question. Now that you know how to perfectly document what happened, how can you start using all of this structured data to predict what's going to happen next? And that, right there, is where the real power of SAP Plant Maintenance truly begins. Thanks for watching. All right, welcome to the explainer. Let's talk about a classic headache for any maintenance planner. How do you get all the parts, all the services, everything you need for a repair, organized and fast? Well, today we're going to show you how the SAP maintenance order is your absolute best friend for getting it done right. Okay, so here's our game plan. First up, the maintenance order itself. Then we'll get into the nitty-gritty of sourcing materials and hiring outside help. After that, I'll show you some really cool tools to make planning easier, and we'll finish up with the key transactions you'll be using every single day. All right, let's kick things off with the maintenance order. Think of it as your command center for the entire job. Picture this, right? It's the middle of a shift, and boom, a critical production pump goes down. You need parts, you might need a specialist technician, and you need them now. So how do you plan the fix? This is exactly where the SAP maintenance order shines. It's not just some piece of paper or a simple work ticket. No, it's your central hub, the one place where you're going to organize every single resource to get that pump humming again. Okay, so you've got your maintenance order created. Now comes the first big question you have to answer. Where are you getting the parts? Do you have them sitting on a shelf in your own warehouse, or do you need to go out and buy them? And this is where the system gets really smart. It uses something called item categories to tell the two apart. If the part is in your warehouse, you use item category L. Think L for Lager, which is German for stock. That just creates a simple reservation. But if you have to buy it from a vendor, you use N for non-stock. And this is the magic part. Using N automatically kicks off a whole purchasing process, starting with a purchase requisition. Getting this right from the start is absolutely crucial because it dictates the entire journey of that part and, how all the costs get tracked. And honestly, the best thing about the internal process is just how simple it is. You add the part to your order, boom, the system reserves it for you. The second you release that order, it checks that the part is actually available, and then you just go and pull it from the storeroom. It's a super clean, really efficient flow. Everything just works. Okay, but what if you're working with a more advanced warehouse, one that's run by SAP's Extended Warehouse Management, or EWM? Well, the process is pretty much the same, with one really important extra step. The system creates what's called an outbound delivery. You can think of this as the official instruction manual for the warehouse guys. It tells the EWM system exactly what to pick, pack, and get ready for the maintenance crew. Now, for the other side of the coin, buying something externally. And this is the whole shebang. When you plan a non-stock item, you're not just ordering a part. You're triggering a complete purchasing cycle that runs in the background. It starts with the requisition, then the purchase order gets created, the part gets delivered and received, and finally, the vendor's invoice gets paid. And the most important thing to remember here is that every single step is automatically tied back to your maintenance order. That means your cost tracking is going to be flawless. All right, so materials are sorted. Awesome. But what happens when the problem isn't just a broken part? What if that pump needs a specialist, someone you don't have on your team? Let's dive into how you plan and hire external services. So in the newer S4HANA systems, there's this really slick approach called lean services. And the idea behind it is actually pretty simple, but it's super powerful. You basically pretend the service is a physical part. You create a special material number for it with the type serve for service, and then you can add it to your order just like you'd add a bolt or a gasket. This makes things so much easier because you don't have to write out a huge, complicated service description right at the beginning. Now, there's a little catch. To use these awesome lean services, your system has to be switched into what's called enhanced procurement mode. By default, it's usually in compatibility mode, which uses the older, more traditional methods. But once you flip that switch to enhanced mode, you unlock all this cool functionality. You can plan services just like materials, using item categories like non-stock or even something called an enhanced limit for those jobs where you're not exactly sure what the final bill will be. So what's the one step that makes this whole thing lean? It's right here. In this enhanced mode, you just add the service directly as a component. That's it. That one simple move kicks off the exact same purchasing process we saw for materials. It's like you're buying a physical thing, which is just so much simpler. Okay, so now let's compare that to the old school way, the standard process, in compatibility mode. In this world, you use a special control key, PM03, to flag the job as an external service. The biggest difference? You have to create a service entry sheet. Think of this as the official sign-off sheet. It's the document you use to say, yep, the contractor did the job, we're happy with it, and that's what lets them get paid. So we've covered the main ways to get parts and services. But wait, there's more. SAP also has some fantastic tools built in to make your life as a planner way faster and a lot more accurate. Let me tell you about two of my favorite time savers. First is the Open Catalog Interface, or OCI. This is so cool. It lets you literally jump from your maintenance order straight into a vendor's online catalog. You can browse their site, pick the part you need, and with one click, pull all that info right back into your order. It's amazing. And second, for all those parts you're buying externally, you can set a specific delivery address. This is a game changer. It means that critical part shows up right at the workshop door instead of getting lost for hours over at the main receiving dock. Okay, so we've talked a lot about the what and the why. Let's wrap this up by looking at the how, the actual transaction codes or T codes that you're going to be using in the system to make all this magic happen. All right, think of this as your planner's cheat sheet. Your everyday go-to transactions are going to be IW31, 32, and 33. That's for creating, changing, and looking at maintenance orders. When it comes to the purchasing side of things, you'll be spending a lot of time in ME21N. MeGo, that's your one-stop shop for all material movements, whether you're receiving a new part or issuing one from your stock. And last but not least, ML81N. That's where you'll manage all those service entry sheets we talked about. At the end of the day, knowing these different ways of working is what makes you a great planner. It gives you the power to pick the fastest, most efficient path for any job that comes your way. So let's think about that broken pump one last time. It's an emergency. You need an expert fast. Would you go with the lean service process or the standard one? Which one's going to get that expert on site with the least amount of paperwork? Knowing the answer to that, well, that's what really makes you a pro at planning in SAP. All right, welcome everybody. Today, we're going to talk about a challenge that every single maintenance planner knows all too well, the pure chaos of scheduling. You know, if you're tired of juggling spreadsheets, trying to figure out who's available and which jobs are on fire, well, you are in exactly the right place. We're going to break down SAP S4HANA's Resource Scheduling Add-on. It's a toolkit designed to bring some serious clarity to all that chaos.
So, here's our game plan. First, we're going to lay out the scheduling challenge itself. Then we'll open up the digital toolkit SAP gives you. After that, we'll walk through building a schedule from the ground up, see how to organize your work, and then finally put all the pieces together. Okay, let's dive in.
First things first, let's talk about the problem. I mean, this is the daily grind for anyone trying to manage a maintenance team and actually get things done. I mean, this is the million-dollar question, isn't it? Trying to juggle all your maintenance activities, you've got your corrective stuff, your preventive, maybe an emergency pops up. It can feel like you're solving this massive puzzle, but you're missing half the pieces, and you can't even see the whole board. And here is SAP's answer, the Resource Scheduling Add-on, or RSH for short. It's a tool built for one purpose: to give you a single clear picture of your team's workload and their capacity. The whole idea is to replace that chaotic puzzle with a clear, actionable plan. So let's pop the hood on this digital toolkit and take a look at the specific Fiori apps that are about to become your new best friends for planning. The heart and soul of this whole toolkit is the Resource Scheduling for Maintenance Planners app. Seriously, think of it as your mission control. This is where you do pretty much everything. You can schedule jobs, dispatch them, see their status, cancel things, move operations around. It's all about bringing your planning into one single powerful space. Now, a really key tool inside this suite is the Work Center Utilization app. Its entire reason for being is to answer one critical question. Is my team swamped, or do they have room for more work? This is your first step to figure out who can take on more and who might be a bottleneck. And this chart just illustrates the whole concept perfectly. On the screen, you've got a super simple visual of two work centers. You can see, clear as day, Work Center A is overloaded. That workload bar is way past its capacity line. But look at Work Center B, plenty of room to spare. With this one visual, you can instantly decide, okay, let's move a job from A to B and balance things out. All right, let's move on to the next tool in our kit, the Maintenance Scheduling Board. This is where your schedule really comes to life. It stops being just a list of tasks and turns into a living, breathing visual timeline. Now, this is what's so smart about this app. Take a look at this hierarchy. You've got your main maintenance order right at the top. Then, nested underneath, are the individual operations, and you can even have sub-operations under those. This structure makes it so easy to see how all the different little pieces of a job fit together. And that amazing hierarchical view is paired up with a Gantt chart. You know, this visual timeline is basically your early warning system. It's where you're going to spot instantly when two different jobs are scheduled for the same person at the same time, so you can fix it before it becomes a real problem out on the floor. Okay, so we've seen the tools. Now let's get into the fun part. How do you actually use them to build a solid maintenance schedule? This right here is a really important concept to get. In RSH, a schedule is like your personal sandbox. It's a private simulation where you can play around, you can move jobs, test out different scenarios, and it doesn't affect the live system at all. It's your draft, and only you can see it until you're ready to make it official. So this four-step process is how it all comes together. Step 1, you pull in the new work that needs doing. Then the system is smart enough to automatically add what's called the base load. That's all the work that's already committed. Then comes the fun part. You simulate your changes in your private sandbox. And once you've got it just right, you freeze it, and bam, it's the official schedule. So building a schedule is one thing, but keeping it organized is a whole other ballgame. You can't just have a giant random list of work orders, right? That's where maintenance events come in. They give you a way to logically group related jobs together. Now, for any of you SAP veterans out there, this is a key point. The whole idea of bundling work orders for a big project, like a shutdown or something, it's not new. In the old school SAP interface, it was called a revision. In the new, modern Fiori world, it's called a maintenance event. Same great taste, just a different name. So when you create one of these groups, you've got to categorize it. This is all set up in the system's backend, what we call customizing, where you define different types. So you might have a simple planning bucket for your day-to-day stuff, or you could have more complex types for those huge projects that need tighter controls. It just helps you structure all your different kinds of maintenance work. And here it is. This is where things get really, really powerful. These tools for organizing your work, they don't live on an island. They are deeply integrated across the entire S4HANA system, and that just unlocks a whole new level of efficiency. This is an absolute game changer. Why? Because maintenance events are part of standard S4HANA, not just a feature of the add-on. That means they become this universal tag for your work. You can create a maintenance event for, say, annual shutdown week 3, and then use that single tag to filter and find those specific jobs absolutely everywhere. And this slide right here is the proof. Look at this list. You can use your maintenance event to filter work not just in the special scheduling apps, but also in standard S4HANA apps like Find Maintenance Orders. This kind of consistent filtering makes managing even huge projects so much simpler. And that really is the bottom line, isn't it? This whole tool set is about taking you from being reactive to proactive. It gives you the power to actually see your workload, to simulate different plans in a totally safe environment, and to structure all your work in a way that just makes sense. So there you have it, a quick tour of SAP Resource Scheduling. I guess the real question is, now that you have the tools to see everything all in one place, what's the very first scheduling conflict you're going to go out and solve? All right, let's dive in. Today, we're going to talk about a really crucial step in SAP plant maintenance. It's the journey an order takes after you've done all the planning. You see, just creating the order isn't the end of the story. It's all about making sure it's 100% ready for action. So let's explore how that actually happens. So, imagine this. You've planned out all the work. The tasks are there, the components are listed, everything looks good on paper. But is that order actually ready for a technician to pick up a wrench and get started? Well, the short answer is, not quite. There's this vital process that acts as a bridge between just planning the work and actually doing the work. And who builds that bridge? That would be the maintenance planner. You really want to think of the planner as the mission controller for the entire maintenance operation. Their job is to be that final critical quality check, making sure every single order is primed and ready to go before it ever hits the shop floor. So what does that mission look like in practice? Well, it really boils down to 3 core things. First, they have to be absolutely positive that all the materials and spare parts needed are physically there. Second, they get all the paperwork, or these days the digital work packs, all sorted out. And finally, they're the ones who hit the go button, releasing the order at just the right moment for work to begin. Now, to get all this done, the planner doesn't just wing it. No way. They follow a super systematic step-by-step process. It's basically a pre-release checklist to make absolutely sure nothing gets missed. So let's walk through what that actually looks like. Okay, from a bird's eye view, this checklist has 4 key stages. First up, you've got to select the right group of orders to work on. Then you do a really thorough material availability check. After that, a capacity check, to make sure the team can actually handle the work. And finally, a super important evaluation of any safety permits. For now, we're going to zoom in on a couple of these key steps. Let's kick things off with the material availability check. Now, this is way more than just glancing at a list. It's a specific function inside SAP that goes and checks your inventory to confirm that every single stock item, every nut, bolt, and filter you need for that job is actually sitting on the shelf in the right quantity. Its whole purpose is simple, but it's absolutely vital: to stop work from grinding to a halt because a tiny part is missing. And what's really powerful here is how flexible SAP S4HANA is. You're not just stuck doing this one way. You can check a whole list of orders at once using a Fiori app. You can schedule a background job to check thousands of them automatically while you're sleeping, or you can just zero in on one single high-priority order. It's all about giving the planner the right tool for the job, no matter the scale. All right, so the materials are confirmed. Now we move on to something that's, even more important: clearing the safety gates. Before anyone even thinks about starting the work, this system helps make sure all the safety rules are followed and everything is in place. This isn't just a friendly suggestion. It's a hard stop in the process. So SAP kind of tackles this with what you can think of as 4 main pillars. You've got your standard safety permits that can be assigned automatically. For the really complex stuff, like in the utilities industry, there's a super robust module called Work Clearance Management, or WCM. Then you have these modern web-based tools for building out detailed safety plans. And finally, you can even hook it directly into your main risk management systems for a complete 360-degree view of any hazards. Okay, so materials are confirmed, safety is cleared. Now we've arrived at the big moment. This is the final step before execution, giving the order the official green light. This is the act of actually releasing the order But releasing, it's so much more than just changing a status from planned to go. It's like turning a key that unlocks a whole bunch of other activities that you just couldn't do before. So what does it actually enable? What does it unlock? The impact is huge. Once it's released, you can finally print out the instructions. The technician can officially go to the warehouse and withdraw the materials. You can book receipts for any outside services you're using. And here's the big one. Technicians can start confirming their time against the job. Basically, the order becomes a live, breathing thing that starts collecting costs. Okay, the order is live. Now, how do we get all the details into the hands of the person who's actually going to do the work? This is where we see a massive difference between the old way of doing things and the modern S4HANA approach. Let's take a look at how that communication has totally changed. Back in the day, as you can see on the left, it was all about these individual shop papers. You'd have a separate job ticket, a separate material pick list, a time ticket, all of them manually set up and pointed to a specific physical printer. But now with S4HANA Output Management, it's this centralized, much smarter system. Instead of single pieces of paper, it bundles everything into these flexible work packs, and it can send them anywhere. To a printer, sure, but also straight to a technician's email. So what in the world is a work pack? Just think of it like a smart folder. It's basically a collection of something called job packs, and each one of those groups together specific tasks and all the related documents. Safety sheets, diagrams, instructions, all into a single package. It's just a much more organized and efficient way to get the instructions out there. Now listen up. This is a really important one for all you future SAP consultants and system admins out there. When you decide to turn on the modern S4HANA Output Management, you are making a choice. The old school traditional printing functions get turned off. That print button will now use this new system. It's pretty much a one-way street, so it's a big decision. Okay, to wrap things up, let's take a quick look at the Planner's Toolkit. If you're coming from an older SAP system, you're probably used to all those T-codes. In S4HANA, everything is moving to these modern Fiori apps, but a lot of the old transactions are still hanging around. It really helps to know how they map to each other. And here it is, a fantastic little cheat sheet. If you used to live inside transaction IW38 to find your maintenance orders, well, your new home is the Find Maintenance Orders Fiori app. Were you using IW38A to schedule that material check? Guess what? Now there's an app for that. This is a great little reference to help translate what you already know into the new S4HANA world. So when you pull it all together, we've seen a ton of new tools, right? Background jobs doing checks for you, these flexible work packs, super intuitive Fiori apps. It all leads to this final, really interesting question. With all this automation and efficiency, how do you think the role of the maintenance planner is changing? Are they moving away from just being an administrator who clicks buttons and becoming more of a strategist who's actually optimizing the entire maintenance process? That's definitely something to think about.
All right, welcome. Today, we are really getting our hands dirty with a super important process in SAP plant maintenance. We're shifting gears from all the planning and approvals and jumping right into the action, actually executing a maintenance task. And we're going to focus on that very first critical step, how a technician actually gets the parts they need for the job.
So let's put ourselves in the shoes of a technician. The work order is approved, it's ready to go, and there's a machine that needs fixing. What's the first thing you've got to do? Well, you need your tools and your materials, right? This whole explainer is about that crucial moment, the material withdrawal process right inside SAP.
And this all kicks off in what we call the execution phase. This is the moment where all that careful planning finally hits the shop floor. It's where theory becomes reality, and it all starts with the system guiding the technician every step of the way.
Now, the execution phase covers the whole hands-on part of the job, from start to finish. But for us today, we're really going to zoom in on one key piece of that puzzle, grabbing the materials you need from the warehouse. It sounds simple, but in the world of SAP, this one step is part of a really slick, integrated process.
The official term for this is material withdrawal. It's the formal act of taking parts out of inventory and, really importantly, assigning their cost and usage to your specific maintenance order. I mean, without the right parts, the job can't even get started.
And that's the big question, isn't it? In a perfect world, every single bolt, filter, and widget is planned out ahead of time. But let's be real, maintenance work can be unpredictable. The good news is, SAP is built to handle both the expected and the unexpected.
So SAP basically thinks about this in two ways.
Over on the left, you've got your planned withdrawal. This is the ideal scenario, right? It's for all the stuff you knew you'd need from the get-go. It was in the plan, it was reserved for your order, the system is basically waiting for you to pick it up. But then, there's the unplanned withdrawal. This is your lifesaver for when a surprise pops up. You're halfway through the job and realize you need an extra part. That's an immediate on-the-spot request.
Okay, now here's where the magic really happens. When you do either one of these withdrawals, something incredible is going on in the background. It's not just about a person taking a part off a shelf, it's about setting off a digital ripple effect across the entire SAP system.
And this little flowchart shows that ripple effect perfectly. It starts in step 1, in plant maintenance, or PM, where the technician withdraws the part. Instantly, and I mean instantly. In step 2, the materials management module, MM, sees this and automatically reduces the stock count. At the exact same time, over in step 3, the system is posting documents in finance and controlling, or FI/CO, to account for the cost of that part. This is what makes SAP so powerful. You've got one single physical action by one person, and it triggers all these automatic digital updates across totally different departments. No extra phone calls, no lag time, no paperwork. It's just incredibly efficient.
Okay, so you get the what and the why now. Let's talk about the how. What does a technician actually use in the system to say, hey, I'm taking these parts. Let's look at the tools of the trade.
Generally speaking, there are two main ways you can do this. You've got the SAP Fiori Launchpad, which is the modern, slick, web-based interface with all these easy-to-use apps. And then you have the classic, powerhouse SAP GUI, which a lot of seasoned users are very familiar with. For our purposes, we're going to focus on the key transactions in the good old GUI.
Think of this as your personal cheat sheet. Now, while you might use IW32 or IW38 to make changes to orders, the real star of our show today, the one you absolutely need to remember, is the transaction code MIGO. MIGO stands for Post Goods Movement, and it's the main transaction you'll use to formally record that you've taken materials from the warehouse for your job. This is where you make it official in the system.
And this quote really brings us back to that behind-the-scenes magic. When you use MIGO to post that withdrawal, the system is doing all the heavy lifting for you. It automatically figures out all the right financial accounts and posts the costs directly to your maintenance order. You don't have to be a finance whiz, it just works. So there you have it. You've successfully used MIGO to get your parts. They're in your hand, the system is totally up to date, and you're ready to do the repair. But that brings us to our final question for today. Once the actual work is done, what's the next critical piece of information you need to capture to tell the system how long the job really took?
All right, welcome everyone. Today, we're going to tackle a really crucial final step in any maintenance process in SAP, and that's the confirmation. Basically, it's how you tell the system, hey, the job is officially done. So let's picture this. The job is done, you've repaired the equipment, the tools are put away, the machine's humming along nicely again. But in the world of SAP, the work isn't truly finished until you've told the system it's finished. So how do you actually close that loop? Well, that's exactly what confirmations are for. So here's what we're going to cover. First, we'll talk about why confirmations even matter. Then, we'll get into the big difference between time and technical confirmations. After that, we'll jump right into the how-to for logging your work time and then documenting all those technical findings. And don't worry, we'll cover both the modern Fiori apps and the classic SAP GUI. Okay, first up, why do confirmations even matter? I mean, why bother with this extra step? Why not just close the maintenance order and call it a day? Well, it's because the confirmation is so much more than just a checkbox. Think of it as the official story of the repair. It captures all that crucial data that you're going to need for any future analysis. So, before a task can be officially marked as complete, the system really needs you to perform these key activities. We're talking time confirmation, technical confirmation, and of course, getting those measurement or counter readings. Each one of these captures a different but equally important piece of the puzzle. All right, now this is where it gets really interesting. See, SAP doesn't treat all confirmations the same way. It actually splits the whole process into two very distinct types. And honestly, understanding this difference is the absolute key to getting your data right. First up, you've got the time confirmation. This one is super straightforward. It's purely about logging the how long, right? The actual labor hours you and your team spent on a specific operation. It's all about the time. And then, on the other side, we have the technical confirmation. This is where you get to document the what and the why of the job. You're capturing all those juicy technical details, the damages you found, their exact locations, and, this is a big one, what caused them in the first place. So let's break that down, because this is the crucial point. Time confirmation, that's all about labor hours, and it gets posted against the maintenance order. Technical confirmation, that's for all the nitty-gritty details of the fault, and that goes against the maintenance notification. They're like two sides of the same coin, but they get recorded in totally different places. Super important to remember that. Okay, enough theory. Let's get practical. How does this stuff actually work in the system? We're going to start with logging your work time using the modern tile-based SAP Fiori apps. And honestly, it's a really straightforward process. You just open up an app like Perform Maintenance Jobs, find your task, and enter the actual time you spent on it. As soon as you hit post, boom, the system immediately updates that operation status to partially confirmed, or PCNF for short. And this is what we're aiming for. This is the final goal. Once every single operation on that maintenance order is confirmed, even just partially, the status of the entire order flips over to Finally Confirmed, or CNF. That's your green light. That's what tells you all the work has been officially logged. Job done. And hey, don't worry about making a mistake. It happens to the best of us. We're all human. One of the key features here is that if you happen to enter the wrong data or, assign time to the wrong operation, you can always go back into the system and reverse a confirmation. No big deal. Okay, so we've talked about time. Now for the other side of that coin, the technical confirmation. This is where we document our findings, and let me tell you, this is absolutely vital for building a reliable maintenance history that helps us and the whole company get smarter over time. Now, this isn't just about noting that, hey, something was broken. It's about putting on your detective hat. You need to capture the root cause, the specific tasks you performed to fix it, the exact location of the damage, and this one is crucial, the impact it had on the machine's availability and downtime. And here's why this matters so much. This data, it isn't just getting filed away somewhere to be forgotten. No way. It becomes the foundation for all future analysis. This is how you start to spot recurring problems. It's how you improve equipment reliability. And ultimately, this is how you start preventing failures before they even happen. It's a total game changer. Okay, but what if you're not on Fiori? I know many of you still work in the classic SAP graphical user interface, the good old GUI. Don't you worry, because there's a whole set of powerful, dedicated transactions for handling confirmations there as well. Here's a look at the most common transaction codes or T-codes that you're probably going to use. You've got options for everything, right? From a simple individual time confirmation with IW41 all the way up to powerful collective confirmations like IW48, which lets you process a whole bunch of orders at once. And here's a great thing to know. These T-codes work whether you're using the classic desktop application or you're accessing SAP through a web browser with the HTML GUI. So these trusted, classic tools are always there for you to get the job done. So next time you go to close out a maintenance order, just remember this. You're not just finishing a task. You're contributing a vital piece of data. You're basically an author, writing the next chapter in the story of your equipment's life. So what kind of story will your data tell? All right, let's talk about one of the most critical parts of the whole maintenance process in SAP plant maintenance, finishing the job. And I don't just mean packing up your tools. I'm talking about telling the system the right way that the work is officially done. So picture this. The part's been replaced, the machine is humming along again, the team's cleaning up. The job's done, right? Well, in the world of SAP, the answer is a big, fat nope, not yet. You see, the work isn't truly finished until the system agrees with you. And that's exactly what we're going to break down today. Okay, here's our roadmap. First, we'll get into why a finished repair doesn't automatically mean a finished job in SAP. Then, we're going to look at the two sides of the completion coin, the order and the notification. We'll see how they play together and, why doing this right is absolutely essential for your data down the line. To really wrap your head around this, you have to understand a fundamental concept in SAP PM. Closing out a maintenance job isn't just one click. It's actually a process with two totally separate sides, one for the folks doing the maintenance and one for the folks in finance. First up, we have what's called technical completion. Just think of this as the maintenance supervisor giving the official thumbs up. From their point of view, the physical work is done and dusted. This step basically freezes the order from a logistics perspective. No more parts, no more planned time against it. Then, on the other side of the wall, you've got order settlement. This is all about closing the books,
financially speaking. Every cost that was racked up on that maintenance order, labor, materials, you name it, gets officially posted to the right place, like a specific department's cost center. This is the controlling team's world. So let's look at them side by side, because this makes it super clear. On the left, you've got technical completion. We call it TECO. That's the maintenance team saying we're done with the wrenches. On the right, you've got the financial wrap-up, making sure all the money is accounted for. Two different functions, two totally different goals. All right, let's dive a little deeper now. We're going to start with the part that the maintenance team is directly responsible for, getting that maintenance order to TECO status. And here it is, the magic word, TECO. It stands for technically completed. When you see the status on a maintenance order, that's the system's official stamp saying the maintenance work itself is finished. Now this is where it gets really interesting. The second an order is TECO'd, a whole bunch of stuff happens automatically. Any open reservations for parts? Gone. Any labor hours that were set aside? Freed up. This is huge because it instantly cleans up your planning and scheduling. It stops someone from accidentally trying to use resources that aren't needed for this job anymore. It's like a big system reset. But, and this is a big but, TECO isn't a permanent, unbreakable seal. SAP knows things happen, so you still have some flexibility. You can go back and add timesheets that someone forgot to enter, and really importantly, the finance team can still post late invoices against the order. This is so key for getting the costs right. Okay, so that's the order. But remember, an order doesn't usually live alone. It's almost always linked to a maintenance notification. And closing out that notification, well, that's the other half of the story. It has its own rules and its own status. Now, before you even think about completing the notification, it's a really good idea to run through a quick mental checklist. Is the equipment number right? Did we mark all the little tasks as done? Is the breakdown info filled out? This is all about making sure that historical record is rock solid. And this right here is the notifications version of TECO. It's called NOCO, which stands for Notification Completed. This status means the whole story of the problem and the work done is now considered final and closed. And you got to be careful here, because unlike the TECO order, NOC is way more permanent. Once it's done, it's locked. You can't just go back and edit the details. This is what sets the official date for reporting in the Big Plant Maintenance Information System, or PMIS. And that data, it feeds directly into super important reports, like mean time between failure. So the real trick is understanding how these two things, the order and the notification, fit together. You can complete them one at a time, or you can do it all at once. But there's one really important rule you have to know about. Let's play out a scenario that happens all the time. What if you try to complete everything, but someone on the team forgot to check off one of the tasks inside the notification? What do you think happens? And here's the answer. The system is smart. It will let you technically complete the maintenance order. You can TECO it, but it will absolutely stop you from completing the notification. The logic is pretty simple. You can't close the history books if there's still tasks that are supposedly not done yet. Now, we're all human, right? What happens if you TECO an order too early? Maybe a last-minute part shows up, or you discover a little more work that needs to be done. Well, the good news is you're not stuck. SAP lets you reverse the technical completion. When you reverse TECO, it's like hitting the undo button. The system puts everything back exactly how it was. The order becomes active again, the reservations for materials pop back up, and so do the capacity requirements. It's a really powerful feature to have in your back pocket. So to actually do all of this, here are the tools you'll need. IW32 is your best friend for changing one single maintenance order. That's where you'll go to set that TECO status. And if you've got a whole list of jobs to close out at the end of the week, IW38 is the transaction that will let you do them all in one go. Okay, so we've walked through the steps, the statuses, the rules, but let's zoom out. Why do we even bother with all this? This brings us to the final and honestly the most important takeaway of all. This quote right here really says it all. Every single time you correctly complete an order and a notification, you're not just checking a box. You are building your plant's maintenance history. And that history is absolute gold. It's what you use to figure out why things are breaking, to justify new equipment, and to plan your future work smarter. And that really brings us to the bottom line.
Every report, every fancy KPI dashboard, every maintenance strategy you come up with, it all depends on the quality of this history. Your data is only as good as your last closed order. So the next time you finish a job, just ask yourself, how accurate is the story I'm telling the system?
Imagine this. An alarm is blaring, a critical machine is down. In the world of plant maintenance, that's when the clock starts ticking, and literally every second counts. In this explainer, we're going to walk you through the entire emergency maintenance workflow in SAP S4HANA. You know, from that moment of breakdown all the way to getting you back online fast.
So here's our game plan. We'll kick things off with the breakdown itself, then we'll see how the issue gets reported and how the repair is planned. After that, we'll follow the technician as they get the work done, and we'll wrap up with a look at something called the overall status. It's a really cool feature that gives everyone a complete, real-time view of the entire job.
Okay, picture it. You're out on the shop floor, and suddenly an alarm goes off. Production just grinds to a halt. The pressure's on, right? In a moment like that, having an efficient, clear process isn't just, a nice to have. It is absolutely essential.
This is really the moment of truth. That clock is ticking, and what you do in these first few moments is crucial for a quick recovery. So with all this pressure, where do you even start inside a system like SAP?
Well, the answer is a single, really powerful app that's built for this exact scenario. It doesn't matter if you're at a desktop or using a phone right there next to the broken machine, this tool is designed to guide the technician from that initial report all the way to the final fix. It's all in one seamless workflow.
All right, so the very first step is to create a clear, accurate record of what just went wrong. And this isn't just about paperwork, trust me. This is the foundation for getting a fast and successful repair done.
The app basically walks you through 4 core steps. First, you find the exact piece of equipment in the system. Then you describe what's going on, you specify its location, and this part is critical, you assess the effect. Is it a safety issue? Is it stopping production entirely? This helps prioritize the work from the get-go.
And here's where the process gets really, really powerful. A technician who's on a mobile device can just snap a quick photo of the damage and attach it right then and there. They can even pull up the machine's recent repair history on the spot, which, is invaluable for figuring out if this is a recurring problem.
So with the problem reported, we now shift from just describing what's wrong to actually planning how we're going to fix it. This is where we start assigning people, defining the tasks, and reserving the parts we're going to need for the job.
So planning begins by creating what are called work items. First, you assign the job to the correct maintenance team, what SAP calls a work center. Then you can pinpoint a specific person for the job. You'll describe exactly what needs to be done, and you'll estimate how long it should take. The key here is just clarity. Everyone knows who is doing what and when it needs to get done.
Of course, you can't really fix a machine without the right parts, right? So the system gives you 3 really smart ways to find them. You can pull from the official bill of material, you can look at parts that were recently used on this same machine, or you can just do a general search. This flexibility makes finding what you need way faster. And here's a huge time saver that's built right in. As you pick a part, this system is checking the stock in real time. See that little green check? That means the part is available. This simple feature prevents a massive delay. No more assigning a part and sending someone to the warehouse only to find out it's not even there. Okay, so let's switch perspectives for a second. We've planned the work, but what does the technician who's assigned to the job actually see? Well, they pretty much live in a feature called My Job List, and it's basically their personal command center.
This job list is incredibly flexible, and it really empowers the technician to manage their own workflow. They can filter to see just their own jobs, but they can also see what their whole team's working on, maybe to see if a coworker needs a hand. There's even a view for unassigned jobs, which lets a technician proactively grab the next urgent task without having to wait for it to be assigned. So as the work is happening, documenting the progress is just as important as actually turning the wrench. The technician can start and pause the job, recording the actual time spent, and crucially, they document the technical details using standardized codes for the damage, what caused it, and the activities they performed. This creates this amazing, high-quality data record that's vital for future analysis and, hopefully, preventing the same failure from happening again.
So, we've reported, we've planned, and we've executed the repair. Now we get to the big payoff. Following this whole process unlocks one of S4HANA's most powerful features for maintenance visibility.
It's called the overall status. And this isn't just another field on a screen. It's a complete, live view of the entire emergency work order. From the second that malfunction is reported to the final confirmation, everyone, from the technician to the planner to the supervisor, can see the exact, up-to-the-minute status of the job in one clear, simple indicator. And that kind of brings us back to our big question. When you give your teams a single, intuitive app that provides real-time data and transparent status tracking, you're doing a lot more than just fixing a machine. You're transforming that emergency response from a chaotic reaction into a structured, data-driven process. And that is what leads to smarter and faster repairs.
Hey, if you're an SAP plant maintenance student, you are in exactly the right place. We're about to break down a topic that is absolutely central to your entire career: preventive maintenance. So let's just get right into it.
So I want to start things off with a question for you. Just picture any factory, any plant, really any facility that's got complex machinery. What is the one thing, the single biggest enemy that can bring everything to a grinding halt? If you said unplanned downtime, you absolutely hit the nail on the head. That, and of course, its very, very expensive cousin, high maintenance costs. I mean, these are the two nightmares that literally keep plant managers awake at night. And they're the core business problems that you, as an SAP professional, are going to be hired to solve. So, how do we fight back against this? Well, we do it by shifting our mindset, right? We move away from a reactive firefighting mode to a proactive strategy. And that strategy is what we call preventative maintenance. This is all about getting ahead of the problem before it can even start. This quote right here really gets to the heart of it. The goal? Super simple. Keep downtime and costs as low as possible. And the method is pretty simple in concept too. Regular inspections and maintenance. That word, regularly, that's the key. That is what makes all the difference. It's all about being planned and being disciplined. But, regularly can mean a lot of different things for different pieces of equipment. See, preventative maintenance isn't some one-size-fits-all solution. There are actually 4 distinct approaches, kind of like 4 flavors, and choosing the right one is a huge strategic decision.
First up, we've got time-based maintenance. This is the most straightforward type you'll find. Just like that calendar icon suggests, it's all about the clock. An activity gets triggered simply because a certain amount of time has passed. Think about changing the oil in your car every 6 months, no matter how much you've actually driven it.
Okay, next we get a little bit smarter with performance-based maintenance. So instead of time, the trigger here is usage, like that odometer you see. Sticking with the car analogy, it's like when maintenance is due after, say, 10,000 kilometers. This is way more efficient, because the work is based on how much the asset has actually been used. Now with condition-based maintenance, we actually start listening to the equipment itself. Here, maintenance is triggered only when a measurement from a sensor, like this temperature gauge, goes outside of a safe, predefined range. We're not guessing anymore. We're responding to the real, live health of the asset. And finally, we have the real cutting-edge stuff, predictive maintenance. This is the future, and it's happening right now. By using real-time data from all these IoT sensors and cloud-based analytics, this approach doesn't just respond to a condition, it actually predicts a failure before it happens. This lets you step in at the absolute perfect moment. So, what's the big takeaway here? It's all about the trigger. This table just perfectly illustrates the evolution. We go from a simple, elapsed time trigger to a usage counter. Then we level up to monitoring a specific value range, and finally, we're analyzing complex data patterns to predict the future. This is the whole spectrum of strategies you'll be working with. All right, so now that we get the what and the why of these strategies, let's dig into the how. For you SAP students, this is the good stuff. This is the practical, 5-step workflow you're going to see and use right inside the system to bring all these strategies to life. Here's the entire process, just at a glance. It all kicks off with a task list, which then feeds into a maintenance plan. That plan gets scheduled, which automatically generates a maintenance order for someone to actually do the work. And then, finally, it's all closed out with technical completion. Let's just quickly break each of these down. First up, the task list. You can think of this as the master recipe. It's the detailed, step-by-step instruction manual that defines exactly what work needs to get done during the maintenance activity. Which bolts to tighten, which filters to change, what to inspect, all of it. Next is the maintenance plan. Now, this is the strategic heart of the whole process. This is where you link the what, our task list, to the where, which is the specific piece of equipment, and crucially, the when, that's the maintenance strategy, like time-based or performance-based, that we just covered. After that, we have scheduling.
Think of this as the automated engine that makes the whole thing just run. You set it up once, and the SAP system takes over, regularly checking all the maintenance plans and automatically generating the work orders at exactly the right time. This is the power of automation right there.
So what comes out of that scheduling engine? Well, it's the maintenance order. This is the official, actionable work ticket. It's the document that shows up in the technician's queue, telling them exactly what to do, where to do it, and when. This is where the plan becomes real, physical work.
And finally, we have what is maybe the most important step for keeping this whole cycle going: technical completion, or what you'll call TECO. When the technician finishes the job, they complete the order in the system, and this action is so critical because it feeds the completion date back into the maintenance plan, which lets the system accurately calculate the next time the work is due. It closes the loop. It's beautiful.
Okay, so we've gone through the theory and the nuts and bolts of the steps in SAP. But why does all this matter? What's the real-world impact of the work you'll be doing when you actually master this process?
Well, it all comes down to this: one single proactive process. It matters because it lets a company move away from dozens of chaotic, reactive firefighting moments. This isn't just about fixing things when they break, it's about taking complete control over the health and the entire life cycle of your most valuable assets.
You know, the pure elegance of this system is captured perfectly in this one sentence. It describes this self-sustaining, intelligent loop that you're creating. Every single time a job is completed, the system learns from it and perfectly plans the next cycle. It's just a continuous loop of proactive care.
So I'll leave you with this final thought. We've seen this whole spectrum, right? From simple time-based plans all the way to these complex predictive models. As technology like the Internet of Things continues to totally transform manufacturing, the real question for you is this: which of these types of maintenance will you choose to specialize in for your career?
All right, welcome everyone. We're about to do a deep dive into one of the most powerful and honestly game-changing tools in all of SAP plant maintenance. Today, we're going to break down the maintenance task list, a feature that can totally transform how you manage all that recurring work.
So let me start with a question, and I bet this is going to hit close to home for a lot of you. You know that routine inspection, right? Or that standard repair job? And you find yourself just typing the same operations, the same parts, the same times into a work order again and again and again. It's not just tedious, it's where mistakes happen.
Well, the good news is there is a much smarter way to handle this in SAP. There's a feature that was built specifically to kill that repetitive work. It's how you standardize your processes, save a truly massive amount of time, and just make your entire maintenance planning way, way more effective.
Okay, so let's get into it. The solution is called the maintenance task list. The best way to think of it is as the ultimate blueprint, or maybe a master template for any job you do on a regular basis. You set it up perfectly one time with all the details, and then you just reuse it forever.
So what is it exactly? Well, the official SAP definition says it describes a sequence of individual maintenance activities. I kind of prefer to think of it as a master recipe for a maintenance job. It's got all the ingredients, the parts, and all the steps, the operations, laid out in the perfect order to get a perfect result every single time.
And the benefits here are just huge. I mean, they go way beyond just being convenient. First, you standardize your work. This is a big deal. It means every single technician does the same job the exact same way, which is absolutely critical for quality and safety. Second, you can plan so much better because all the details are already figured out. And third, the one everyone loves, the time savings are just enormous. We're talking a complete game changer for efficiency.
And look, you don't have to just take my word for it. This quote comes straight from SAP's own documentation, and it nails the core value. The key phrase here, with minimal effort. I mean, isn't that the dream? That's the whole goal, to take something complex and make it as simple as just pointing to a plan you already built.
So what's actually inside one of these things? Let's pop the hood and take a look at the anatomy of a task list. It really just breaks down into two main sections. You've got the header, and then you've got the operations.
First up is the header. Think of this like the cover sheet for the whole job. It holds all the high-level, big-picture information. It answers the who and the what. You'll define things like the planning plant, which is really just the location responsible for planning, and the planner group. That's the specific team in charge. This is where you set the overall strategy for the entire task. Then, after the big picture, you get to the real heart of the task list, the operations. This is the nitty-gritty. It's your detailed, step-by-step,
how-to guide. For every single step in the job, you spell out the work center, that's who's actually doing the work, how long it should take, what spare parts and materials are needed, and any special tools you might need. Okay, now this next part is super important. Task lists really come in two main flavors. First, you have object-dependent ones. These are tied to one single piece of equipment or a specific location. Think of it as a custom-tailored recipe for one unique, complex machine. Then you have object-independent or general task lists. These are the templates you can apply to many similar things, like having one standard procedure to inspect every single fire extinguisher in the building.
And this is the magic moment. This is where all that setup pays off in a huge way. When a planner goes to create a work order, they don't have to start typing from a blank screen. Nope. They just create the order, reference the task list, and bam! In a split second, SAP copies everything, all the operations, all the parts, all the times, right into the order. A process that might have taken 20 minutes of careful typing is now done in 20 seconds. That is the power we're talking about.
Okay, let's get really practical. How do you actually do all this in SAP? Well, if you're someone who works in the system every day, you know that you live and die by transaction codes or T-codes. So let's look at the key ones you're going to need to know.
Here you go. This table is basically your new cheat sheet. If you're a maintenance planner, these T-codes are about to become your best friends. And you know, the great thing is, SAP actually made them pretty logical. See the pattern? For a general task list, it's IA05 to create, 06 to change, 07 to display. For equipment, it's 01, 02, 03. For functional locations, 11, 12, 13. Memorizing these is going to make you so much faster.
So, what's the big takeaway here? The most crucial point is this. A maintenance task list is so much more than just a time-saving trick. It is a powerful way to capture the knowledge of your most experienced people. You are literally turning their expertise into a standardized, reusable, and efficient asset for the entire company. That's incredibly powerful.
Okay, so to wrap this all up, I'm going to leave you with a question. I want you to think, right now, about your own workplace, or maybe what you're studying. What is that one recurring, time-consuming maintenance job, the one that everyone just groans about, that is just begging to be standardized? Now that you have the tool, what's the first process you would go and improve?
Let's be real. If you've ever worked in maintenance, you've felt that panic of a sudden equipment failure. It's a constant loop of reactive repairs, right? Well, today, we're going to get a handle on that. We're going to demystify two core SAP tools designed to get you way ahead of the game: single cycle and strategy maintenance plans. Let's break down how you can finally move from firefighting to future-proofing. So, here's the game plan. First, we're going to talk about the big picture problem, that whole proactive maintenance challenge. Then, we'll dive right into the SAP tools, breaking down both the simple single cycle plans and the more advanced strategy plans. And to finish up, we'll look at how you actually put these plans into action in the real world. Sound good? Let's go. Okay, first things first, let's set the stage here. The entire goal, the whole reason we're doing any of this, is to shift how we operate. It's about moving away from just reacting to problems as they pop up and instead actively preventing them. Going from chaos to control. This is really the million-dollar question for any maintenance department, isn't it? Are you spending your days just putting out fires, running from one unexpected breakdown to the next? Or are you calmly executing a smart, well-thought-out plan that keeps your critical assets running like clockwork? And just so we're clear, this isn't some small theoretical issue. The stakes here are incredibly high. Every single minute of unplanned downtime is a direct hit to the company's bottom line. We're talking lost production, crazy overtime costs for repairs, rush orders for parts, you name it. That's why having a solid system isn't just a nice to have, it's absolutely essential. So what's the solution? How do we fix this? Well, lucky for us, SAP gives us a really powerful set of tools to automate the whole process. Let's start by breaking down the fundamental building blocks, the maintenance plans themselves. At its very core, a maintenance plan is basically a super smart scheduler. Its one and only job is to watch the calendar or maybe a performance counter and say, hey, it's time to do this task again. Then, poof, it automatically creates the paperwork, like a maintenance order or a notification, so that nothing ever gets missed. But wait, how does the plan know what to do and where to do it? Well, that's where the maintenance item comes in. Think of it as the glue that holds everything together. It connects the what, say a specific pump motor, with the how, which is the detailed, step-by-step task list of the work to be done. And this is key. A single plan for a huge machine might have multiple items, one for the engine, another for the hydraulics, and so on. All right, let's start with the most straightforward tool in our toolbox, the single cycle plan. This is your workhorse, your go-to for all that simple, repeatable maintenance work. The two words you really need to remember here are same and regular. It's kind of like setting a simple alarm on your phone. It goes off at the same time every single day to remind you to do the exact same thing. It's predictable, it's consistent, and it's absolutely perfect for those tasks that never change. And these examples are perfect. An annual fire extinguisher check. Yep, that's a single cycle plan. A technical inspection that happens every 2 years? For sure. The system will just trigger the exact same complete task list every single time that interval pops up. So simple, but so effective. Okay, but let's be honest, not everything is that simple, right? What about your really complex machines, where different tasks need to be done at different times? For that, we need a much more sophisticated tool. So let's dive into strategy plans. This right here is the game changer. A strategy plan is built for what we call graded maintenance. This is where you might have a small inspection, a medium-level service, and a major overhaul, all happening at totally different frequencies, but all for the same piece of equipment. The car maintenance analogy is hands down the best way to understand this. Think about it. You don't do the exact same service on your car every 6 months, do you? Of course not. You might check the air filter every 6 months, but you only change it every 12. You might check the fan belt at 12 months, but only replace it every 24. A strategy plan handles all of that complexity automatically. So you're probably wondering, how does SAP pull this off? Well, it's basically a 4-step recipe. First, you define your overall strategy. Then, within that strategy, you create different packages. Just think of these as your different time cycles, like a 6-month package, a 12-month, and a 24-month. Next, you link that whole strategy to your master task list. And finally, the cool part. You assign each individual task to a specific package. It gives you incredible flexibility. Okay, let's bring this all home. It's time for a practical summary where we compare these two plans side by side and, most importantly, give you the key transaction codes you're going to need. This slide pretty much says it all. For single cycle plans, think simple and fixed. The entire task list gets triggered every single time. Easy. But for strategy plans, think complex and flexible with those graded intervals. Here, only specific tasks from the list are triggered depending on which package is due. It's all about using the right tool for the job. All right, for all you SAP students and future power users, this slide is gold. Get ready to take a screenshot. These are the transaction codes, or T codes, you'll be using constantly. IP41. That's how you create a simple, single-cycle plan. For the more complex strategy plans, you're going to use IP42. The others here are for changing or just looking up plans and items. Seriously, you'll want to remember these. And this quote really brings us full circle, doesn't it? The whole reason these tools even exist, the entire purpose of mastering single-cycle and strategy plans, is to hit this one critical goal: to cut downtime and control costs by doing smart, regular, planned maintenance. So, I'll leave you with this question. Now that you understand the difference between a simple, repeating plan and a more complex, strategic one, think about your own world. Which of your critical assets are just crying out for a proactive maintenance plan? And, more importantly, which of these tools is the right one for the job? You ever look at a massive factory and just wonder, how do they keep track of everything? I mean, hundreds, maybe thousands of preventative maintenance tasks. Well, today, we're going to pull back the curtain on the secret sauce inside SAP Plant Maintenance that makes it all happen automatically. We're diving deep into maintenance plan scheduling, the key to making sure nothing, and I mean nothing, ever gets missed. So seriously, how does a system like SAP juggle thousands of maintenance tasks for a whole company without ever dropping the ball? You know, it really feels like it should be magic, right? But the answer is actually incredibly smart and, believe it or not, pretty logical. And here's that answer. It's all about something called maintenance plan scheduling. Now, I want you to think of this as a tireless robot working 24/7 in the background of your SAP system. It's this always-on automation engine that is constantly watching over all your maintenance plans, making sure everything is triggered exactly when it needs to be.
Okay, before we can really get our hands dirty and start using this thing, we've got to learn to speak its language. There are a couple of foundational terms you absolutely need to know because they unlock everything else we're going to talk about. So, let's break them down. First up is the term we just mentioned, maintenance plan scheduling. At its core, this is that background job that is permanently on guard, and it has two main jobs. First, it automatically creates the work orders, what SAP calls call objects. And second, it does all the math to figure out the future due dates for every single task. Simple as that.
And our second key term is scheduling functions. So if maintenance plan scheduling is the engine, think of these functions as your dashboard, your control levers. They are the specific commands like start or new start that you use to tell that powerful engine exactly what to do and when to do it. All right, let's explore that control panel. We're about to break down the 5 main scheduling functions you'll be using to make all this automation happen. Trust me, mastering these 5 functions is the key to unlocking the true power of SAP PM. Yep, just 5. That's really all you need to know to get started. But here's the catch. Each one has a very specific, very important purpose. And knowing exactly which one to use in which situation, well, that's what separates the beginners from the real pros. Let's get into it. Let's kick things off with 2 functions that sound almost identical but are worlds apart. Start versus new start. Think of start as your big green launch button. You press this when you've got a brand new piece of equipment that's just being put into service for the very first time. New start, on the other hand, is your do-over button. It's what you use when, whoops, you started a plan with the wrong dates or parameters, and you need to wipe the slate clean and start it over correctly. Next, we have the scheduling function. This one is the real workhorse, the heart of your day-to-day automation. It works like a domino effect. As soon as one maintenance order gets completed and closed out, this function automatically wakes up and creates the next one in the sequence. It's this beautiful, self-sustaining cycle that's all triggered by just getting the work done. Okay, now for a really powerful one, start in current cycle. Just imagine this scenario. You're moving all your maintenance data into SAP from an old system, maybe even from paper records. You don't want to lose all that history and start from day one, right? Well, this function is your lifesaver. It lets you jump into an existing maintenance cycle right in the middle, exactly where you left off. Let's make that a little more real with an example. So, picture this. You have a plan with maintenance tasks scheduled for 1 month, 4 months, and 6 months. Now, your equipment is already 5 months old, and you've already done those first 5 monthly checks outside of SAP. To get on track, you use Start in Current Cycle. You tell the system, hey, the next big thing is the 6-month package. And then, this is the crucial part. You tell it the exact date that the 5th monthly check was completed. SAP takes that info and boom, perfectly schedules that upcoming 6-month job right on time. And finally, we have manual call. This is your big red override button. You know, most of the time, you want the system to run on autopilot, but every now and then, you just need to step in and create a maintenance order for a very specific, non-standard date. This function lets you do just that. It gives you complete manual control for those special occasions when you need it.
So, we've seen all the functions that can trigger the scheduling process. But what's actually happening behind the scenes? Let's peel back another layer and look at the timeline, from that first calculation all the way to the moment a real work order pops up in the system.
The whole process really boils down to 3 key dates. It all begins with the cycle start date. Think of this as the starting line in a race. It's the anchor point for every single future calculation. Next comes the call date. This is the day the system actually generates the work order. It's often set weeks in advance to give you time to order parts and plan resources. And finally, you have the plan date. That's the finish line. It's the actual target date for when the technicians should be doing the work. Okay, enough theory. Let's get practical. How do you actually do all this stuff in SAP? This next part is all about your toolkit, the essential transaction codes, or T codes, that are your gateway to everything we've just talked about. And here they are. These are the codes you're gonna want to remember. IP10 is your everyday tool for scheduling a single maintenance plan. Now, if you need to schedule hundreds at once, IP30H is gonna be your best friend. It's a total lifesaver. If you want to play around and see what would happen without actually creating any orders, you use IP19 for simulation. And finally, to just get a nice clean list of all your scheduled plans, you pop into IP24. These 4 T codes, absolutely fundamental for any SAP PM Pro.
So there you have it. You now understand those 5 core functions, from start to manual call, and you know the key T codes to bring it all to life. You basically have the blueprint for putting your entire preventative maintenance program on autopilot. The power is literally at your fingertips. So the real question is, what are you going to do with it? When you look at your own processes, which one are you going to automate first?
Have you ever wondered how maintenance techs manage all their complex jobs when they're out in the field, maybe up a tower or deep in a factory? Well, today we're going to pull back the curtain on the SAP Service and Asset Manager. It's a powerful mobile app that's really changing how this kind of work gets done. So let's dive right in.
Here's what we've got on tap. We're going to start with the basics. What is this thing? Then we'll get into the good stuff, the core tools a tech guru uses every single day. After that, we'll look at some of the more advanced features, peek under the hood at the tech that makes it all work, and then we'll wrap up with the biggest takeaways you'll want to remember.
Okay, first things first. What exactly are we talking about when we say SAP Service and Asset Manager? Let's break it down.
So think of this as a super specialized tool that runs on both iPhones and Androids. It's built to work right out of the box, but here's the cool part. It's also incredibly flexible. It's metadata driven, which is just a fancy way of saying it can be molded to fit how a specific company works. And it's built on SAP Fiori principles, which basically means it's designed to be as intuitive and easy to use as the apps you use every day.
All right, let's get to the nitty-gritty. If you're a maintenance tech, what's actually in this digital toolkit that you're going to be using all day long?
This is the big question, right? How does a tech even know what they're supposed to do when they're miles away from a computer? The whole system really starts with something called jobs. The heart of the app is the job. That's basically your digital work order. It's your to-do list, and it gets beamed directly from the main SAP system to your device. But what makes this so powerful is that it's not a one-way street. A tech can create new jobs on the fly if they spot something unexpected, or even create a follow-up job for later. That is absolutely critical for how maintenance actually works in the real world.
Let's be real. Maintenance work is often unpredictable, and this is where the app truly shines. You can create a notification for a sudden breakdown, pull up the entire history of the machine you're working on, log new readings from a sensor, and even plan and order the exact spare parts you need for the fix. It connects the dots from problem to solution, all in one place.
And then there are these awesome features that just make life easier. Forget scribbling on timesheets. Your time is tracked automatically, though you can always edit it. There's a built-in map to show you where your next job is. You can pull up manuals, attach photos of your work, whatever you need. You can even set little personal reminders for yourself so nothing falls through the cracks.
Okay, so we've covered the core tools. Now let's level up and look at some of the more advanced capabilities that handle trickier situations and different types of users.
So picture this. You've got a team of techs, and they're all sharing one single, rugged tablet over 3 different shifts. This is a super common scenario. So how do you make sure everyone's work stays separate and secure? Well, the app has a clever solution for this called multi-user support.
When you go to log out, the app is smart. It gives you options. You can either sync all your completed work right then and there, or you can pass the baton and let the next person's login trigger the sync. Or, hey, maybe you hit the button by accident. You can just cancel. It's this kind of flexibility that keeps the data clean when you have multiple people using one device.
Now for a really, really cool concept. Personas. The idea here is simple but powerful. Not everyone needs to see everything. The app intelligently changes what you see and what you can do based on your specific job role. It just filters out all the noise.
For example, a maintenance technician sees an interface that's all about repairs and work orders. But if a service technician logs into that same device, their view might be focused on customer information. And if an inventory clerk logs in, boom, it's a completely different view tailored for managing parts. The key is you only see what's relevant to you, which makes your job way faster.
And the list keeps going. There's a clock in, clock out feature that lets several techs work on one huge job and log their time separately. You've got digital checklist for inspections, which is huge for compliance. It supports something called the EAM phase model for really structured, complex jobs. And there's even an add-on for field service folks that helps with planning out their routes for the day.
So we've seen what the app can do. Now let's take a quick peek under the hood to see how it all works.
So you might be wondering, how does a work order created on a computer in an office magically appear on a phone out in the field, especially if there's no internet connection? It's a great question, and understanding the answer is key to seeing why this is so reliable.
Let's follow the data on its journey. It all starts in the company's main brain,
SAP S4HANA. A special add-on sends that info securely up to the SAP Business Technology Platform, or BTP. You can think of BTP as the air traffic controller in the cloud. It manages all the data and, crucially, handles the offline capabilities. From there, it lands safely on your phone, ready for you to get to work.
So right now, the app works with on-premise SAP S4HANA systems and uses Esri for its mapping. But what's really exciting is what's coming next. Support for S4HANA Cloud is in the works, along with SAP's own powerful mapping tools. So this thing is constantly evolving. Phew! We have covered a lot of ground. So let's bring it all home and recap the most important things to remember.
It really just boils down to 3 main points.
First, just think of it as a technician's digital toolkit, one that's actually easy and intuitive to use. Second, it's comprehensive. It handles the entire workflow from the moment you get a job to the moment you sign off. And third, it's flexible and modern. It adapts to you through those personas we talked about, and it's built on a really solid cloud-based foundation. And all this leads to one final question for you to think about. As our work becomes more and more digital, what do you think the next big challenge, or maybe the next big opportunity, is going to be for technicians out there in the field? Definitely some food for thought.
Welcome to The Explainer. Today, we're diving into the brains of SAP S4HANA Asset Management, and that's its analytics. We're going to demystify how you can turn all that raw maintenance data into smart, actionable decisions. Let's get right to it.
Okay, let's start with this idea. Think about any piece of equipment you're responsible for. Every single repair, every cost, every minute of downtime. That's not just a bunch of numbers in a database. It's a story. And the real question is, are you actually listening to what that equipment is trying to tell you about its health? So here's our game plan for how we're going to decode that story. We'll start with the absolute foundation, the data itself. Then we'll look at the 2 main paths you can take to analyze it. We're going to see some really cool Fiori apps in action, zoom out for the big picture with strategic tools, and then wrap it all up with a quick recap.
All right, first things first. Let's talk about the absolute bedrock of every single thing we're going to discuss today, your maintenance history.
Every time a technician finishes a work order, or someone creates a maintenance notification, they're adding to this history. But this isn't just some boring logbook. No way. This is the rich, raw material that fuels every report, every chart, every forecast you're ever going to make. Seriously, without a good maintenance history, you're just flying blind.
Okay, so you've got all this great data. Now what? Well, SAP S4HANA gives you 2 totally different ways to turn it into actual insight. And knowing which path to choose and when is absolutely key. So let's break this down. Embedded analytics. Well, it's baked right into S4HANA. It's what you're going to use for your day-to-day real-time questions, like a maintenance supervisor asking which machine is breaking down the most right now. Strategic analytics, on the other hand, is the big picture powerhouse. This is for when you need to combine data from, say, multiple plants over 5 years to make a huge investment decision. The easiest way to think about it, embedded is your daily toolkit, and strategic is the heavy machinery you bring in for the major projects. All right, let's get practical. For most of your daily grind, you're going to be living inside embedded analytics, using these really slick modern interfaces called Fiori apps. So let's pop the hood and see what makes them tick.
The magic behind these apps, the thing that makes them so fast, is something called Core Data Services, or CDS views. Now, in the old days, you might have had to wait for an overnight report to get your data. Forget that. CDS views are like having a direct, live window into your database. The second a work order gets updated, boom, you see it in your analytics. It's instant intelligence. And that brings us to 2 of the most common Fiori apps you'll probably use: Technical Object Breakdowns and Technical Object Damages. The names are pretty self-explanatory, right? They give you an instant visual breakdown of what's failing and why.
And what makes these apps so awesome is how intuitive they are. You've got your filters up top to slice and dice your data. In the middle, you get a nice big chart so you can spot trends visually. And at the bottom, there's a detailed table. And here's the best part. You can literally just click on a line in that table and drill all the way back to the original notification that started everything. It's super powerful.
Okay, for all you future maintenance planners out there, listen up. This next app, Actual Cost Analysis, is about to become your new best friend. It is all about keeping an eagle eye on the budget and figuring out where every single dollar is actually going.
The journey here is just so simple and powerful.
First, you can filter your costs by just about anything you can think of. Order type, manufacturer, you name it. Then, you visualize it. A classic move here is to compare the cost of reactive, it's broken maintenance, versus your planned preventative maintenance. And finally, you can drill right down to see the exact work orders that are costing you the most money. You go from a big question to a specific answer in seconds.
And hey, if you want an even bigger financial picture, there's the Maintenance Order Costs app. This one takes it a step further because it pulls in your planned and estimated costs too. So you can see right on one screen what you thought you were going to spend versus what you actually spent. Super useful stuff.
All right, so we've totally nailed the day-to-day operational stuff. But what happens when you need to zoom out? You know, when you have those big questions that cross different systems and need some serious business intelligence muscle? Well, that's where strategic analytics comes into play. This is your heavy-duty analytics toolkit. It really has two main parts. First, there's SAP Business Warehouse, or BW. Think of this as a massive, super organized central library where you pull in data from all over the place. Then you have SAP Business Objects, or BO, which is this whole suite of tools that let you build amazing reports and dashboards using the data from your library.
And this table is basically your cheat sheet for that Business Objects toolbox. You've got different tools for different jobs, right? If you need a perfectly formatted pixel-perfect report for the bosses, you'll grab Crystal Reports. If you just want to explore data and build a cool interactive dashboard, Lemire is your go-to. Or maybe you love working in Excel. Then you'd use Analysis for Office to dig for trends. It's all about picking the right tool for the job.
Whew, okay. We have covered a ton of ground here, from real-time operational stuff to long-term strategic trends. So let's do a super quick recap of the essential tools in your new analytics toolkit.
So if you remember anything, remember this. It all starts with your maintenance history. That's non-negotiable. For your daily, in-the-moment questions, you're going to use embedded analytics. Think Fiori apps. And for those big, complex, multi-system head-scratchers, you unleash the power of strategic analytics with BW and business objects. The whole secret is just matching the right tool to the right question.
And you know, this really gets to the heart of it all. Your maintenance history, that's a perfect record of what already happened. It's the past. But analytics is what gives you the power to use that past to predict, to improve, and to shape a much better, more efficient future.
So as you keep going on your learning journey with SAP, I'm going to leave you with this thought. The real question isn't just what do these tools do? It's how am I going to use them? Which expensive breakdown are you going to prevent? Which process are you going to make run smoother? That's the real challenge. And the cool thing is, now you've got the toolkit to solve it.